This is Wix Studio, built to meet any brief. When the brief calls for complex structure, let AI
Oh yeah. What's up, everybody? Welcome, welcome, one and all. What's up, Matab? It might just be you and me in here today. Nah, I'm just kidding. We got some other people in here. SolidWorks at last, yeah. All right, guys, welcome, welcome. My name is TooTallToby, certified SolidWorks expert, on-shape enthusiast. I love on-shape. We can see Guntis is in the chat, and it's perfect timing because if you look at Guntis' YouTube channel, and you should be able to link to it right from his name, but Guntis, if you want to drop that channel in the chat, I will rebroadcast it as well here. Otherwise, I don't think I have a quick link to it that I can get to. Maybe I do in the, I guess I could probably find it here in the, hold on, I'll share my screen in a second. Let me just see if it's in here real quick. It's probably right in here, right? Yeah. Oh, yeah. Let's go. Okay, here we go. So, guys, if you go to Guntis' YouTube channel, shout out to Guntis. Constance in the chat. He's done almost all these models in Onshape. And so I figured what we could do here today is we could do these in SolidWorks. Thought that would be a nice mix. You get kind of the best of both worlds. So if you want to see these models done by an Onshape wizard, visit Guntis. I just dropped his link here in the chat, and I'll also add it to, I wonder if I could add it to the live stream description here without, he's a pro. Yeah, he's a total pro. Without like totally blowing this thing up. I'm not going to try and add it to the description here. I'm not going to try and blow it up. I'm just going to, I get nervous about just blitzing the whole live stream. So I'm not gonna add it into the description right at this moment, but I will try to remember to add to the description after, and then Guntis, if I forget, you can just let me know in the Discord. All right, let's start over. What's up, everybody? Welcome, welcome. My name is TooTallToby, and welcome to today's live stream. I am a certified SolidWorks expert. We have been hosting the most epic tournament, CAD vs. CAD tournament that you've ever seen. And so today I thought it would be a fun way to kind of get us hyped for tomorrow, get us hyped for the finals by going through and modeling up all of the parts that we've seen so far using SolidWorks. Now, as a lot of you know, I have been quite a fan of Onshape, the Onshape solution. And so I was going to do all these in Onshape, but a good friend of the show, Guntis Constance, has already done it all in Onshape. So if you're here and you're an Onshape fan, check out Guntis's YouTube channel, and he's got all the information there so that you can learn all about how to do what we're going to be doing today using Onshape. But today, we are going to be doing this using SolidWorks. So I've got a build of SolidWorks up here. This is SolidWorks 2020. One of my favorite builds, I think my favorite build of SolidWorks is SolidWorks 2015. But the thing is, in the newer builds of SolidWorks, you get this thing that happens that is actually a deal breaker for me. I'm trying to think of the nicest way to say this. And what that thing is if I go in here to top plane, begin a sketch, and create a fully defined rectangle here, so 42 by 69, and then I extrude that up to a height of 15, and then let's say I get rid of some of this geometry here, just to like kind of make this thing into an L shape. And then let's say I create an extrusion that goes up to a surface. So I'll create an 8mm extrusion here that goes up to surface. So I double click on the surface here and go up to surface. And then I want to create a cut extrude. So I pick this face here and I create a circle that's going to blast through this whole thing. Oops, that was a little bit big. Create a circle that's going to blast through this whole thing. And so I'm going to go through all, or maybe I want to go up to vertex or something like that, or I just want to go blind. I'm just going to make a cut extrude blind here. So I'm going to go S key extrude cut, and then I want to make this blind. So I'm going to go 5mm, enter. And now you see I've created a 5mm extrusion there. Or maybe if we made this a little bit more narrow. So let's say we bring this to 3mm, enter. See, that works. That's a fantastic workflow. It's one that I've kind of honed over a few years. And something that like I want to be able to keep using this workflow over and over and over again. Well, unfortunately, somebody at SolidWorks decided that it would be cool to get rid of that, to make that workflow not work. And so to demonstrate that, I can show you this in SolidWorks 2022. And you'll see here that in SolidWorks 2022, they added this great new enhancement where it remembers what your previous end condition was. And when it remembers what your previous end condition was, what that does for you is it basically eliminates that workflow. So if we do kind of the same thing here, so just so we can kind of see a one-to-one comparison here. So I go top plane, begin a sketch, S key, rectangle, do center point rectangle here, and we'll make this 69 by 40, or sorry, 42 by 69. All right. We're already wrong. We're already doing it wrong. 42 by 69. And then we extrude that. We're just getting warmed up, guys. It's okay. Extrude that out to 15. So you notice that the workflow that I'm talking about here, the workflow in question is S key extrude, and you are immediately dropped into an end condition of blind with the depth of the end condition highlighted. That is perfect. That's what we want. That's what we want by default. That's actually what we want every single time. Matab in the chat is saying, this is actually annoying in the latest SolidWorks builds. Yeah, I'd say it's more than annoying. I'd call it prohibitive. So if we go here to 15, enter, boom, that's a beautiful workflow. So again, that workflow is S key extrude, 15, enter. Move on to the next step. So now let's say we were going to get rid of some of these faces, and we're going to make that 5mm. And now we're going to create an extrusion up to surface. So you pick this face here, begin a sketch, S key, circle, drop in a circle here. We'll make the circle 8mm, extrude. We go double click. So what happens here is when you double click on a face, so double click here, the end condition changes to up to surface automatically. So currently it's blind. I double click on a face, up to surface. Oh yeah, that looks good. Right click, that finishes that extrusion. Oh yeah, everything is looking great here. So now I'm gonna do a 3mm cut extrude. So pick a face, begin a sketch, S key, and we're going to create a 3mm cut extrude here. So S key, extrude cut, 3, enter. What's this? It's like, what's happening here? So I just typed in 3, enter, and you see it says rebuild errors. And the reason it's saying rebuild errors is because the previous extrusion that I did went up to surface. So the extrude command now remembers what your previous extrude command. Well, you know, what's my beef here? Why am I making such a big deal about this? Well, 80-90% of your extrusions are going to be blind. Like almost every extrusion you do is going to be blind. So why would you want it to remember like the oddball extrusion that you did up to surface or up to vertex, especially when these are dynamic? They're dependent on there's a dependency, a secondary dependency here, and that dependency is almost certainly not going to be the same. You know, you're probably talking about like 5% and lower that this is going to actually be the same dependency here. It doesn't remember it anyway, so it's kind of moot, but you know, this is definitely something that is a deal breaker for me. So when people ask me like, why don't you use the brand newest versions of SolidWorks? This is really it. This is like the primary reason why. I mean, there's other reasons. You go on any message board, you can see some of the other reasons why, but this is the primary reason why. This is a deal breaker for me. So as we're going through today, we're going to be using this build of SolidWorks. For any of you out there that make tutorials, that make content online, there is kind of something cool that you can do. You can create your own. Hold on a second. I don't think I have my desktop icon shown. You can create your own shortcut for SolidWorks. So let me show you guys what this looks like. Hold on a second. I had to move this so I could see OBS. Okay, yeah. So here's my shortcut for SolidWorks, and then what you do is. So what this shortcut here is it came from the actual directory, the actual original directory. So it's not the one that SolidWorks puts on your desktop. You browse into your C program files in Windows, and then this is one that is in, like you drag and drop this onto your desktop. So you do like a right click and drag, and it makes a copy. So you'll notice that this is originally came from C program files, SolidWorks, and it's the SLD works.exe. So I did a right click and drag, and I dragged that onto my desktop, and then when you let go of right click, it says like create shortcut here. So you create a shortcut, so it's like a copy of the shortcut, and then you edit this text string here that says target, and you add this onto the end. So I'll drop this into the chat so you guys can see it. So there's what it looks like. C program file, SolidWorks 2020, SolidWorks, SolidWorks.exe, space /SW generic main win title. And so what this does is when I launch SolidWorks, it doesn't show what version of SolidWorks I'm using to the audience. So if any of you are out there and you're tutorial makers, you might like, I saw Chris B. Co in the chat. Shout out to Chris B. Co. I saw Chris B. Co in the chat there. If you ever want to kind of like mask what version of SolidWorks you're using, that's how you can do it. You make a new Windows desktop shortcut, and then you add that onto the end. Little pro tip there from somebody who's done a lot of SolidWorks demos. So what that means is when you look down here in the status bar, it doesn't tell you what version of SolidWorks you're using. And when you look here at it's I don't know what it's called, it's not the splash screen, but if you notice here in the background, it doesn't tell you what version of SolidWorks you're using either. So it's just like a little cool thing you can do if you don't want people to know what version of SolidWorks you're using. All right, guys, that's it for the intro. A little bit different from our standard intros. Yes. Yeah. Every time somebody sees that, they're always, oh, you're using SolidWorks 2022. Why aren't you using the latest one or whatever? They always think they're so smart because they know that there's a thing down here. So there you go. Now you guys can block that. Block those Reddit comments. All right, guys, welcome one and all. Let's get into it. We're going to try and do every single model from the tournament. You can see I've got the Wheel of Fate here. I think that as far as how we're going to do a timer for this, what we're going to do is we're going to use we'll just use the timer that's at TooTallToby.com. We love TooTallToby.com. It's a fantastic place to be. If you guys haven't been to TooTallToby.com before, you should definitely go there. It is the ultimate website to refine your CAD skills regardless of what CAD system you're using. It's got a great front page here, TooTallToby.com. Practice and improve your skills with the gamification of 3D CAD. And here you can see we've got a library of over 200 2D to 3D CAD challenges. So what we're going to do is we're just going to pick one of these, and we'll just use the clock from one of these. So I'll just pick like this one here. And then I'm just going to borrow the clock from this one. Click here to begin, and I'm going to borrow this clock as we are going through and doing our SolidWorks runs. So let's use the Wheel of Fate here to find out why hide the version. This is a good way to debug something if it was working. Emil asks why hide. So yeah, it just lets your videos have more shelf life. Some people, like when they watch your video, they'll get turned off if it's an earlier version. But if they don't know if it's an earlier version, if they can't tell, then like it just lets your videos have a longer shelf life. That's kind of the main reason why you would do it. little behind the scenes. Maybe you guys don't want to know how the sausage is made. All right, let's put this up here. Bring up the wheel. All right, here we go. Guys, if you haven't seen the tournament episodes yet, take a look at the live streams for the tournament episodes. There's lots of good stuff on there. I do want to know this stuff. Yeah, of course you do. Because you want to actually examine the code. Yeah, I know you do, Jern. I know you do, Jern. All right. Unless you're saying you just want to know how to do that. Whatever. I know you're here. You're here for the love and the likes. That's what we're all about. We want to make more sausages. Okay, good. All right, guys. Model number 8, L stub. So what I'm going to do is I'm going to bring up the model here. I think I'm going to see how it goes with screen real estate, but I'm probably going to take that clock and put that clock somewhere that we can kind of keep an eye on it as the speed run is going to make it a little bit more. I'm just going to make it a little bit easier for us to see kind of what's going on screen. I don't want to necessarily like blank out the screen with the clock on screen, and we'll just keep using the same clock over and over again. Hopefully I don't like misclick and stop the whole live stream or something like that. So I'll just put the clock over here like this. I know you guys can't see it yet, and then I'll add an overlay to that. So model number 8, this one was one that I think this is one that Sebastian did. I think this was a Katia matchup. We're gonna take a trip down memory lane, and this model looks like this. Model number 8 is this guy here, the L stub. And the drawing, in case anybody wants to follow along and see how we're doing this, the drawing looks like this. There you go. Nope, that's not the drawing. Sorry. The drawing looks like this. Both those models are very similarly colored. And I do have the music going, and I will be turning up the music because it's how we model, right? You get the music going, and the music helps you get into the mood, helps you model stuff, helps you get it right, helps you be ready. This was a model from that day where like every model was started with a slot command, right? Remember this one? Remember this day? It was a good day. Okay, and let me just see if I can add in that clock so that we can see it. Oh, already exists. Oh, sorry, guys. Should be doing this in studio mode, actually. Stand by a second. I don't want to accidentally show something that I shouldn't show. Show something super top secret. I've already shown you guys some top secret stuff, but I don't want to show you some super ultra top secret. That'd be bad. This one? Oh, I got it on the first try anyway. First try. Okay. We're just gonna drop this in. First try. All right. Congratulations, everyone. We made it. Wish I could put this. I don't want to put it over there. I don't want to mess up the thing. Are you doing all the models? Yeah, we're gonna clear the whole wheel. Okay. How long do you think it's gonna take? That's a good question, right? How long is it gonna take to do all of them? It's over here. It's over here. Wait, when I hit this, is it gonna? Oh, it does kind of miss. Oh, that's okay, right? Yeah, that's okay. Okay, welcome everyone. Welcome to today's episode of Live Modeling with TooTallToby. My name is TooTallToby, certified SolidWorks expert, and we are going to be going through every single model from the tournament. We're going to use the Wheel of Fate to select the models, and the very first model that we've selected with the wheel is this model here. This is the L stub. It came up a few weeks ago in the tournament. If we go down memory lane, this one came up in the round of, I don't know what round it was. Round of 8? I guess it must have been the round of 8, right? Round of 8, and Yeah, exactly. Jern says, we're going into clip mode. That's exactly right. We got to make sure that we are ready to go in clip mode here. And so for those of you that have been following the tournament, this bracket looked something like this. Let's get the bracket up here. And on that day, I believe we were in the match between... Ooh, that's a big bracket. Look at that thing. Let's go. That's some HD action right there. I believe we were in the round of... Sebastian versus Ouya. Ouya K. So it's in the upper right there. It's a little trip down memory lane for everybody. And when it comes to this drawing, you know, when it comes to any drawing, before I get started, what I always try to do is I try to imagine kind of what my workflow is going to be. And I think that for this drawing, the workflow is going to be create the slotted shape, extrude it up, create the cut extrude shape here, cut it over, create this triangle shape here looking down from the top, add in this counter bore, add in these counter bores, add in this little slot on the back, and boom, done. Oh, we got the rib here too, and boom, done. So pretty straightforward. I'm not going to go, it's not, each of these videos is not really going to be a tutorial. I think that as we go on, we're going to just we're just going to blast through as fast as we can. How long do we think that this is going to be? Let's see here. Depends how distracted you get and how much teaching you do. Could be 2 hours easily. Okay, challenge accepted. All right, let's stop talking quite so much. Let's just get into it here. Here we go, guys. This CAD vs. Toby challenge begins in 3, 2, 1, go. Here we go. We're going to put this over on the second screen. Let's bring up our keyboard cam. You guys can see all the cool keyboard shortcuts that I'm using. Put this up here. Actually, we do want to add in the chat here, I think. We want to keep the chat alive. We want to make sure that people know what we're talking about. We're going to have to restart that timer, I think. Clip mode engaged. Where are we going to put the chat? That's the question. I want to be able to see. Maybe we got to move the model. Yeah, move the model. Too much crap on the screen. That's what you guys always say, right? Too much going on. Can't pay attention. All right, there we go. Now we got a little window into the minds and hearts of the chat. That's good, I think. Too small? Yeah, that's good. No space for us. There's space for you. There's always space for you guys. It's right here. It's right here in my tab. It's where I always keep my space for you guys. All right, here we go. Let's do this. This CAD challenge of the L stub begins in 3, 2, 1, go. All right, here we go. Speed modeling mode engaged. ABS, MMGS. Perfect. Good one to start on. Top plane, begin a sketch, S key, slot command. Matab is the only SolidWorks user on Earth who knows how to fully define their slots, but we can at least get the dimensions correct, even though we're not going to be able to get the actual geometry in here. So we'll add in those dimensions afterwards. Radius 26 and length here is 82. Bring that up to the height of 70. God, you guys probably think that I like have all these memorized, but I really don't. I don't remember these at all. We do so many of them, you know. Here's one where we rip back to that original point to create the tangent edge, and then we just put the radius on there. Unfortunately, it's kind of tough to get this to be tangent, so you want to remember that when you're adding tangent here in this spot, you can either do a crossing to get both of those, make tangent, or you can just click on that point and say make tangent, and boom, that is done. And so now we go from, I did it from the wrong spot. We go from here to here. Remember, if you just press escape once, you negate the original selection, but you don't kick yourself out of the actual dimension command. That's another good way to kind of save some time. Make that one 26. This is going to be pick one, hold the other, pick one, hold control, pick the other, let go of control. Pick one, hold the other, pick the other, let go of control. Make those coincident. And then finally the angle 20. How's the music, guys? Is the music too loud, too quiet? I don't want to have to re-edit the music here. This is an open sketch. So in SolidWorks, if you go through all both, then it functions like a surface cut. So I didn't close off that sketch. I did the end condition through all both, hit the green check mark, done with that one. let's just get that rib in there right now just to kind of make this a little bit easier. So here, what we could do for this rib, I'm going to just, instead of getting fancy, I'm just going to draw it as solid. So we start bringing this line down. You put your mouse over this line here, and that wakes it up so that you can add the parallel relationship as you're sketching it. Hopefully that added it. It looks like maybe it didn't. Come across here again. We're going to use that tangent trick again. Make sure that we're horizontal. Come straight down here like so. And then we could take these. If I would have converted these first, I would have locked in that parallel relationship there. Here I'm using a crossing. Save some time by using a crossing there. Crossing. We didn't used to have that tangent from a point, so that's why I use that crossing there. And this distance is 7 and 7. Right? 7 and 7. This is a distance from the point of tangency. Wow. Toby. Mean to these guys. And 24. S key, extrude. Type in the depth first. 10, enter. Then right click, mid plane, right click to finish that. That's another good workflow to learn and to remember. Top plane, begin a sketch. Get a normal 2 here. This is just going to be a real straightforward, create a center line. Remember with this one too, this is like a real pro level trick here. If you go to create a center line and you do it in a click and drag, so like if you look at the keyboard overlay, you see I'm holding down my left mouse button, then that just makes 1. And the reason that's significant is because now I can chain from that right into S key to jump back into line. Now, if instead I did create center line and then I did click, move, click, now I'm in a chain of line commands, and now I either have to double click or I have to press escape before I can press S. Because if I press S now, you see it just tries to put an S in the auto dimensioning. So to get out of this, I could hit escape or I could double click. So double click, and then I could S key line, and that takes me into the next part of this. But you can see here that if you just kind of learn that ultra power move, left click and drag to do 1, you can chain right into S key line and then jump right in the next one. Vicky Chong is in the chat. Says Toby cannot resist teaching. It's true. It's true, guys. It's true. It's how we show our love for the chat and our love for humanity. Let's mirror that bad boy over. Make these guys tangent. Probably should just convert that while I'm here, right? Convert that and make that. I don't know why I'm not using convert from my S key. Trim that bad boy up. And what do we got for distances here? From origin to center of arc, 70. From center of arc to center of arc, 80. Let's go. Radius 16. Is that it? Fully defined. S key, extrude. And then this is kind of, again, like getting into some pretty deep theory, time-saving shortcuts. When you extrude from a face, the face has polarity. So like this kind of gets into a little bit of like assembly management. When you know how when you go into an assembly and you go to mate 2 parts together. So if we have like an L-shaped part here, I'm not doing a good job of drawing this, but if we have like an L-shaped part here, and then we're going to mate that L-shaped part to this part here, and you pick this bottom face here as the mating face, and then you pick this face here. These 2 faces have polarity, and that polarity is running into one another, so that's why it's called anti-aligned. And they have polarity, like if you did flip mate alignment, then this whole thing would flip over, and then the 2 arrows would be facing the same way. So you'd still be mating to that bottom face, but now that the polarity of the 2 faces has flipped and they're facing the same way, and that's called mate alignment aligned. Well, that idea of face polarity and alignment also comes into play when you're doing extrusions and cuts. So if I pick this face and create an extrusion off of this face, the default behavior, the direction 1 default is away, polarity away, so like opposite polarity. And if I go into a cut extrusion, so extrude cut in this direction, you'll notice that the default polarity is that it goes into, so like into the face, away from the face, with the polarity or away from the polarity. So when I say polarity, what I mean is like the face has like a negative, positive, like recognition. Well, when it comes to creating this sketch down here, you'll notice that I created it on the top plane because I know that the top plane polarity is based on the USC. So the plane polarity for the top plane is that direction, for the side plane is that direction, and for this plane here is in this direction. The front plane is in this direction. So what that means is that when you go to do an extrusion, that extrusion by default is going to go along with the polarity of that plane. So this sketch here, sketch 4, you'll notice that if I go into S key extrude, it defaults to extrude up with the polarity of the plane, as opposed to if I right click here and I say edit sketch plane, and then I move it onto this face here, and then SolidWorks does what SolidWorks does best. Thank you, SolidWorks, for always taking what seems to be the most simple task imaginable, taking a sketch and copying it to a coplanar location, but it manages to mess that up. So let me just try it a different way here. So I'll just pick this sketch, Control C, pick this face, Control V. Okay, so there we go. So that at least worked. So now if I take that sketch, which now exists on this face, and I go S key extrude, see, now it wants to extrude by default in the opposite polarity of the face, or like same polarity, whatever, it doesn't matter. It extrudes away from the face. So by default, your sketches are going to extrude in a set polarity, and that polarity does come into play in other locations, but that's why when you go to create a plane, the plane has slightly different colors on the front and the back. So plane 1 here, dark blue on the bottom, light blue on the top, and when you go to define the plane, there's an option here for flip normal. So you see if I say flip normal, you get a little like arrow here that indicates the polarity. And you'll notice that here now it's dark blue on the top and light blue on the bottom. And if you go into your options, there's a section here in options for plane color. So if I go in here to, it's like display plane color or something like that. Display shaded planes. No. There's an option in here for plane color. Maybe it's just in colors. Plane display, here it is. So if you go in here to options, document properties, plane display, you've got a front color, back color, and that's not just like arbitrary. There is an actual polarity that comes off of these planes, and that affects certain things. Like it affects the way mates come together, like I mentioned in the beginning. It also affects the way extrusions take place, and there's other things that it affects too, particularly when you get into like some of the add-ins like routing and things like that. So just some good kind of, again, it's a little bit behind the scenes, but it does cut, it's like a nuanced decision, but it did affect my decision to create that sketch on the top plane rather than creating it on the underside of the part, because now I can take that sketch and S key extrude, and then I can just jump right into the depth. So the depth of that extrusion is 12, enter, and then I can, I think I'll probably create the cut extrude here first. For a cut extrude like this, one of the things I see you guys do a lot, and I love it, and I've definitely learned to embrace this workflow, is to just make this with a slot. Just go like that. Drop a slot in there, put some arbitrary distance on it, or even like make this coincident to that edge, and then all you need to do is put in the width. I love that so much. It's so much like more elegant than a rectangle and having to put in the midpoint of the rectangle to the origin. Like, I just love that so much. So thank you guys for teaching me that. Right click through all, right click. And finally, we can add in our hole wizard. So I usually pre-select the face and then S key hole wizard and then start ripping through the settings. So this is going to be a counter bore. I don't need to see this again, and I'll just keep the custom size just in case I'm jumping around. And then I come down here to the custom size for the counter bore, and I will go, what is this? 24 tab, 36 tab, 13 tab. And then because I always look down here, I notice that SolidWorks likes to kind of like surprise you. Some bonus features here, like near side countersink and stuff like that. So I always kind of jump down there. And then in positions, I pre-selected the face when I jumped in, so it knows that I'm on that face. And I kind of wanted to do that because I knew this point was no longer on that face. So just because I had cut through it, Okay, so that looks good. And then we do the same thing here. Pre-select the face, go to hole wizard, and down to our custom settings. And this one is 10 tab, 18 tab, 5. And then positions, wake up the center point. Boom. Hold your cursor over the circular edge, wake up the center point. Boom. And go to our sensor here and rebuild. And 270.6. Let's see if we got it right. Just kidding. This isn't going to validate. Where's the clock? The clock isn't showing here. Come on, guys. Come on, Toby. Where's the clock? I didn't put it on my keyboard cam overlay. It's okay. It's just the first of many. Okay. So 11 minutes. So if I hit cancel, it'll pause it, right? 11 minutes, 52 seconds. All right. Not bad. Not as fast as our amazing speedrunners, but one down. And was that the correct answer? L-stub 270.6. Yeah, that's the correct answer. So correct answer here, 270.6 L-stub. What do we think, guys? Is anything need to be moved around? Are we happy with the overlay? Are we happy with the, maybe I'll put the model down here. It'll be a little bit less in the way. I think it looks good. All right, super in-depth tricks. I like that. Okay, yeah, thank you. That will be maybe the next one we won't go quite as in-depth. I don't want to run out of time here. We only have so much time together, guys. Okay. Don't forget, if you are out there and you are trying to learn how to be a 3D CAD wizard using any 3D CAD system, visit us at TooTallToby.com. This is a fantastic way for you to get better at 3D CAD, because at TooTallToby.com, you can do these same kind of challenges. You can pick a model from our library and you can say, click here to begin and go. And you can review, or you can reveal the drawing, and you can try to model against the clock. TooTallToby.com, the ultimate place. You stop the clock before entering the mass. I mean, I don't have the validation on this, Kevin. FPV Kev, sorry. Sorry, I don't want to assume that's your real name. So I don't have the validation on this. So I just hit that. You know, we have this thing in the app now for our speedrunners, where like if you're running this and then you realize like, I don't really like the way this is going, I'm gonna run it again. You can click cancel and then you can click reveal again, but it does retain the time. So let's go. Jern says, we've been doing a deep dive on that 0.4 K factor sheet metal bracket with the hole in the bend. I love finding models we can't do easily. Nice, Jern. That is awesome. All right, guys. Next. Visit us, TooTallToby.com. Tell your friends. Message your text chat group. 42 people are watching. Hit the like button. Keep the comments coming in. And rename, or not rename, what do they say? Share, and I don't know. We're winging it, guys. I'm letting my hair down a little bit today. You guys are seeing a little bit more casual version of Toby. Share and reshare. Thank you. That's what I was looking for. Share and reshare. Need some more coffee. I could use maybe another cup of coffee. Yes, please. Yes, please. If that's an option, I would love a cup of coffee. I don't know if she was offering. She works in the next office over. So, but if you're offering, Vic, I would love a cup of coffee. Thank you. Thank you. All right, guys. The wheel is speaking. The wheel is speaking to us. This is like this is one I think we should do live streams like this just for the members of the channel, because this is where you guys get to see me in a little bit more of a casual setting, you know. This is what I like to do, though. This is the fun part. Shaft support. All right, we went right to the next one. Let's do it. That's the other yellow one. Turn the wheel off. Change the model. That's this one. This other yellow one. This is the other one Matab did. I guess the first one was Sebastian, right? Sebastian and Ulia. And this one was Matab and... Who did Matab fight in the first one? We'll find out in a second. All right, if you're at home watching and you want to follow along with, you can take a screen capture of this. You can race me. I'm gonna go a little faster this time, so it'll be a good race. Here is what the drawing looks like. Here's my coffee. Thank you. Wow. Manifest coffee. Thumbs up, let's go. Guys, thumbs up for coffee. Don't forget to hit the like button. And hopefully that was enough time for you to do a screen capture. We're gonna try and get through this. Nahat is here. Hello, welcome. Thanks for joining us. All right. Welcome everybody. This next CAD model. I guess I should open it on my screen, huh? Where I have this over here. This one, shaft support. How do we go about modeling something like this? I'm gonna do it the same way they did it in the tournament. That was good. I like that. Make this L shape first. Solid. I mean, maybe I would make it. I mean, in the real world, I would make it from the top down. I'll probably make this first. That's how I would do it. I'm going to do it the way I would do it in the real world. Here we go, guys. No more talking. Let's just get into it. I'm going to probably say that no more talking like 50 times in this tournament, in this live stream. This CAD challenge begins in 3, 2, 1, go! What is the mass of this part in XXX grams aluminum, 1060 aluminum? Let's get the music up a little bit. We're going to lock in on this one. Guys, tell me in the chat what your favorite part of this model is. And my favorite part's going to be just ripping through it. Up to vertex, right click, LFG. Oops. Right click, reverse direction. That's another good one to learn. S key plane. I'm gonna offset the plane. I'm old school guy, sorry. Yeah, you guys don't like that. We're doing it. It's my model. This is right along this line here. Too easy. Reverse direction. Should have flipped the polarity on that plane, huh? Probably go just right up to the center, right? Did I get that? Coincident at the bottom there. Yes, I did. The kid is good. The kid is good. Right click, reverse direction. Nah, I should have the thickness first. Kit is not good. That's sick. It's a big fillet. So here's one. Enter. Enter jumps you right back into fillet. Use enter to repeat the last command. Good time saver when you're chaining fillets together. And then I'm used to pressing S to start the sketch and on shape. That's why you guys see me doing that instead of just clicking the face. Extrude, right click, through wall, right click. And now I'm pressing N to get normal too. Okay. And now we'll use construction lines. I love this trick. You guys showed me this one too. 25. I guess I could have just done that in the whole wizard, but this is 18, 34, 6, and boom, boom. Right click to finish, and then we look at the sensor, and 2139. And is that correct? Oh yeah, it is. Yeah. 2139. Yeah, I had to make the tunes louder. That's where I get my superpowers from. That's the superpower. Guys, let's see some chat flair. 21, what was it? 2139. 3 minutes 24 seconds. LFG, GG number 2. That's how we get pumped. It's exactly right. This is new to me. Toby time challenging himself live. Love it. Thank you, Undefined Explode. Thank you. FlexiCap is here. FlexiCap OG. Let's go. Ray R in the chat. What's up, my friend? It says incorrect. Yeah, these aren't validated yet. Come on. It's correct. I know it's correct. This is all the challenges I'm doing here on the clock are from the 250709. We don't have all these in the app. So, but I know it's correct. I remember from the tournament. I remember all the numbers. Memorized them all. But I am validating, you know, I'm validating in my own, what do you call it? In my own, I have an answer key. I'm validating it before I stop the clock. Yeah, I'm getting so excited here today. I'm like actually stuttering. I'll get rid of that incorrect so you guys won't see that anymore. That way I'll just stop the clock and you'll see the time. All right. Next. Too easy. Give me a hard one. Where's the TooTallToby website? Why isn't it staying up? Gotta keep that rolling. What do you guys think it's gonna be? We'll find out here together. And we'll take this and let's put this over here. Yeah, that's good. And go. Oh boy. I feel like that's a bad one. Wait, did we get this one? Hold on. This is one we might not even have gotten. This might be a mistype. Did we get this one? Oh yeah, we got this one. Okay, here we go. It's this one. Another yellow one. These are all yellow parts. It's crazy. So crazy. It's the craziest thing you can imagine. Let's get the wheel off of here. Let's go to the drawing. Guys, if you want to follow along with from home, this is what the drawing looks like. I know Crispy Co. and some of the other creators are going to try to race me at some point. So if you want to race me, that's cool too. Bring up this recording and try to race TooTallToby. Classic TTT. Yeah, this is kind of a classic. All right. Guys, welcome. Don't forget, if you're out there and you want to learn more about 3D CAD modeling and how to be an epic 3D CAD modeler and get faster and faster and faster every single day, best way to do that is to practice. And we've got a full library of practice exercises for you. All fully defined models you can rely on. You're not going to find a drawing in here that's missing a dimension. And the reason you know that is because when you look at the dashboard from these drawings, you can see how many people have successfully completed it. So these 173 people would not have been able to complete this if it was missing dimensions. So validated drawings, fully defined, all the dimensions you need. And how do you get good at something? How do you get fast at 3D CAD? You practice. That's it. Just practice. How do you get to Carnegie Hall? Practice. That's how. It's an old joke. But also a wise anecdote. My favorite kind of joke. Guys, a tricky one in this one is how to locate this tombstone. It's on a compound angle, but the customer defined this as being 19 millimeters to the corner, which is kind of a weird way of defining this. So for me, this one, these types of things come up. The way you do something like this is you just draw a sketch, and then you just reference that sketch. You reference that sketch for the plane. You reference that sketch for the width of the tombstone. You just reference that same sketch over and over again, and that'll make short work of a challenge like this. But it's still a really fun challenge. So let's get into it here. We'll leave the music down for this one. This one is going to go quick. Everything look good? Everything sound good? That tombstone has seen better days. Yeah, it's going to lean it over. Compound angle, though, is a good skill to know how to do if you're in the world of 3D CAD, regardless of what CAD system you're using. You can learn more about 3D CAD over at TooTallToby.com. Here we go, guys. This CAD challenge begins in 3, 2, 1, go. Here we go. This is in 1060 aluminum MMGS again. We're going to try and do every single model from the tournament today, and we're going to see how fast we can model these up. This one is, whoops, clock's in the way. No fair. 77. Oh, great. Hold on, I'm taking a mulligan, guys. Mulligan. Here we go. This CAD challenge begins in 3, 2, 1, go. Okay, 1060 aluminum MGS. Top plane. Let's go. Still going to center this thing. I'm a sucker for centering. I covered the dang dimension again. I'm so silly. 105. extrude. This is one where I would definitely use the auto filleting for the corners. You know, even though there's only 4 here, it's still, you begin the fillet, you type in the radius of the fillet, which is 14, and then you just pick this one and then move your mouse up and get all of them and then right click OK. Like, that's still a super efficient workflow. And then we can start getting in here and adding in this angled line. This one is at 19. And the angle here is 60. And then the distance to that corner from this edge here is 65. That should fully define it. And then you just exit that sketch and then pick this surface, pick that line, S key, reference geometry plane, and the angle of that plane is 75, leaning back. And now you've kind of set yourself up for success, because now all you need to do is just convert that line and then create the remaining tombstone lines. So that's really the magic of that one, is recognizing how to kind of set yourself up for success with that tombstone sketch. You could do this one as a counterbore. I think when I do this one, I usually include the through hole in the tombstone, because then I just center the counterbore on top of that. Although I don't know why I do that. I know that I do it every time, but I don't know why. Right click, reverse direction, and depth is 12. And then begin a sketch and circle. We're going to make short work of this one, baby. And this is going to be... Oh, I know why, because that dimension's in a weird spot. That's probably why I do it. And that's going to go to 6. And then pre-select this face if you want, and then hold wizard. It's on my S key. I don't know why I didn't get it from there. And that is going to be 10, tab 22, tab 4. And positions is going to be 1, 2, 3, 4. All right, and sensor control Q to update that sensor 303.5, and that was anchor base. Oh, 303.58, so 303.6. 303.6, and boom. 247. LFG. Like it. All right, on to the next. Any questions on that one? Making it look so easy. Whoops. Throw up the chat. I'll bring it up. Why not? There. Did this one as a multi-body move body. That tombstone is in better days. Toby says, how do I make this model harder? Let's make dimensions barely make any sense. Yeah, sometimes, I mean, it's kind of like how the real world is, Theodore. That's how you get napkin sketches from people, and they're like, well, I know the tombstone needs to fit in the slot when it's sliding in, you know, in orthogonal direction. So here, make sure you hold it in these dimensions, and then you kind of have to like back calculate what that's supposed to be, back engineer what that's supposed to be. All right, here we go. We're going to just move right along. We're getting into a groove here, guys. This is what we like. Let me know if anything's too loud, too quiet. And let's turn back to our friend, the Wheel of Fate. Here we go. That one was 14. Oops, I meant to remove that. Let's get rid of 14 there. And let's see what the wheel has up for us next. Thank you, Vicky, for the coffee. It's delicious. Okay, number 4. The peg stop. It's called peg stop. So for those of you out there that are following along with, if you want to try to grab a screen capture, you're welcome to model along with. See if you can beat me. You think you can beat me? Let's go. I'm ready. Missed an opportunity to use the slot tool. Yeah, exactly. I think somebody did use it in the tournament, and I was super happy about it. All right, and one more thing we have to do here is grab this here. Peg stop. This one's pretty straightforward. I mean, it is in inches. We don't mind that. I've done plenty of stuff in inches. All right, everybody. I hope that was enough time for you to grab a screen capture. And if you would like to get better at 3D CAD, make sure you visit us at TooTallToby.com. That's where I do all my practice. People have asked me, how do you get so good at 3D CAD? Do you use MacroPad to get good at 3D CAD? I'm looking forward to using MacroPad from our sponsor of the featured models, macropad.io. They are in kind of pre-release right now, so but we are looking forward to them shipping, I believe, next month. I got to look at the timeline again, but looking forward to getting that. But I primarily use out-of-the-box stuff. I primarily use out-of-the-box shortcuts and keys. I don't really go too crazy with my customized setup, but I will be using that MacroPad for some of the production stuff here at TooTallToby. And I'm going to try to soup it up for Onshape as well. Be a little bit more efficient in Onshape. But the nice thing is, if you are out there and you want to, if you have a MacroPad and you want to learn how to develop it, learn how to make it optimized for your workflows, there's no better place to go than TooTallToby.com. Sign up for the Practice Models app, and then you can practice and practice and practice and figure out what shortcut keys make sense on your MacroPad. Guys, let's get into this next challenge. Here we go. We are in SolidWorks. Let's reset the clock here. All right, here we go. And this one is, we are looking for, I'll spoil it for you guys. We're looking for the answer, 0.98 pounds. 0.98 is the correct answer. So a little bit of a spoiler here. And a great opportunity to use the slot tool. So let me know in the chat if everything sounds good, if anything's too loud, too quiet, if the music's too loud, too quiet. I'm hoping that when this is all over, I can just rip these out as standalone videos. And it'll give us a bunch of content. Be good content. All right, here we go. Speed modeling this peg. Stop in 3, 2, 1, go. What is the mass of this part? This is in inches and pounds. I'll tell you what the answer is. It's 0.98. ABS, IPS, top plane, begin a sketch, S key, slot. We'll make this one a center point slot. Mix it up a little. And like so. Dimension 4. Yo, this thing's big. By 7, hold shift here. Remember, hold shift to get your tangent dimensions. Maybe. Shift. See that? I was able to hit escape and just go back one step. How cool is that? Love that. Just go back one step. It's good to know. You don't have to escape all the way out. You don't have to restart your whole thing. This is one that I probably would do with a bunch of layout work, or at least I'd be tempted to. 0.5. And then you could click on the top plane, hold control, and drag that down if you wanted to kind of give yourself that base plane at the bottom. Again, this is how I would do it IRL. I would go 1.75 offset from top. And then I would know that this is my plane down at the bottom. One thing I remember a long time ago, I saw, I think it was Ed Eaton. I hope I'm not, maybe I'm crediting the wrong person. It was either Ed Eaton or like Mark Biosati. He said, use Windows, bring up your character map in Windows. So you see I've got my character map here. That was totally inadvertent, but if you shake in Windows, if you shake a window, you can minimize and then re-maximize everything. Weird. But bring up your character map, and then if you look through your character map, you can find certain characters that you want to use to represent certain features. So if you're doing, for example, layout work with planes, you could take this shape here and copy it, and then you could go into your SolidWorks tree and you could dump that shape in like emojis. And then that way, at a glance, you and your team would see it. So I dropped that in there 3 times in the name of that feature. You know, it could just as easily be 1 time. But you and your team, at a glance, can see, oh, okay, that's a special feature. That's a feature that's used as like the foundation for everything else. So if that was a layout sketch or like an important surface that you were using to drive the rest of the model, it's kind of a cool thing that you can do. You can bring up character map. It's good to, like, this is something where you'd probably want to have a poster on the wall or like a printed out piece of paper on the wall so your team knows, like a triangle, you know, a triple triangle means this. And so if they see a feature in the tree and it's got the triple triangle, that means like, this feature is really important. It's used as a layout feature for a bunch of stuff down below, so be really careful with this feature. Or that's where you're going to find all the key dimensions or something like that. But I thought that was really clever and like a nice way to kind of, you know, in lieu of being able to actually color code these features, it's kind of a nice way of signaling to yourself and to your team what certain features are doing. Shout out to whoever told me that trick. I think it was Mark Biasati or Ed Eaton. Or Andrew Lowe. I'll just give the credit to Andrew Lowe. Whatever. Shout out to Andrew Lowe. Fantastic guy and a great 3D modeler. See, this is where I mean, certainly in Onshape, I would just draw all these circles from the top view and just use them all. I'm probably going slightly the long way around here. But I'm also kind of modeling it the way I would in the real world, because people always, they're always like, oh, it's not about speed. It's about, it's about making models correctly so they can be updated. But like, it should be about both. It should be something where you're not doing something differently just because it's a speed modeling contest. You should like just learn how to do it fast. It's just like playing scales in music. Like, you learn how to play scales fast in music, but that doesn't give you the license to be sloppy. You still got to play the right notes. Then that's your TooTallToby lesson for the day. So yeah, even though we're speed modeling, I still would do it like this because it just makes it easy to kind of rename the tree, and it makes it easy to, it makes it easy to edit this later too. So like this one here, this would be like main larger shaft. This would be upper smaller shaft. Oops, spelled that wrong. Smaller shaft. This one here would be upper slot. This one would be smaller hole. I'll call this one smaller bore. And then this one here would be C bore at bottom. So went through, renamed everything. Go here, sensors, rebuild. 0.98. Came up with the correct answer. 0.98. And did it in 4 minutes and 40 seconds. So the point is, and we even did that like little mini lesson in there in the middle about this. So it's like if you learn these speed modeling skills, if you practice, you go to TooTallToby.com, you practice. We're not encouraging you to practice bad skills. It took me 5 minutes to do that whole thing, and we even did a little mini lesson in the middle. And that's a perfectly valid, fully constrained feature tree that's going to be really easy for me and my coworkers to edit later. So if you agree with that methodology, if you agree with that philosophy, put a 1 in the chat. We appreciate all the ones, all the support. And we are going to get into the next challenge in this TooTallToby live streaming marathon, modeling every model from the tournament. 4 minutes, 40 seconds. Let's go. Hello from the Philippines. Hello, watching from the Philippines. Great to see you in here. Thank goodness for UTF-8. I don't know what that is. What is that, Jern? Hopefully it's not like a curse word or something. You're tricking me. I don't know all this new slang. Guys, welcome back to the Wheel of Fate. We're going to try and model every model from the tournament. We're going to clear this entire wheel. Let's give this thing a rip. Okay, number 15. Oh, this was such a fun one. Number 15, let's go. The table stand. This one was so fun to watch. It was so fun to model. It was a cool one to come up with. It's a really, really fun model here. This is model number 15. So if you guys want to follow along with, if you want to challenge me, see if you can model this faster than me, then the drawing looks a little something like this. And while that drawing is up on screen, I'm going to get the rest of my assets ready for this presentation. And then we're going to see some serious CAD modeling here. And this baby hits 88 miles an hour. We're going to see some serious CAD modeling. All right. Hope that was enough time for you to do the screen capture, because now we are going to get into it here using 3D CAD. If you guys are out there and want to learn more about 3D CAD, you want to become an expert, you want to hone your skills, get as fast as Toby, well, there's one place you can go to do that. One place only. TooTallToby.com. Access the full library of 2D to 3D CAD models. This is where you can practice, refine your skills, improve your workflows, learn about all the little nuanced things that we are talking about. And Matav in the chat says, Discord exploits went crazy with this one. Yeah, this was a pretty cool one. All right, so this is a multi-body challenge, although it doesn't have to be, but I think it makes sense to be. And you can see here that the way that this thing is manufactured is that we have one shape that is used over and over again, 4 different places. And then we make some changes to that shape. We make this slot that goes through the front, and then we make this little circle here that goes through the side. If you have the time to sit back and think about this, it's pretty straightforward, the approach you would want to take. But if you're just looking at it for the very first time, it can be a little overwhelming. It can kind of catch you by surprise. And that's what made this such a fun model during the tournament. So if you haven't had a chance to see that episode, go back and take a look. It was a lot of fun to watch. But we are going to get into this right now, modeling this against the clock. So this is called table stand. The answer that we're hoping for here is 663. Let's see if we can get it correct. Switch over to my keyboard cam, reset the clock, and go. What is the mass of this part? New part here in red oak in millimeters. And for this one, I think it makes sense to start out on the top plane and create a rectangle with the dimensions 65 by 65. Those are, of course, the center-to-center dimensions, or the center dimensions here for the gap between these four pieces. And the reason that is valuable is because now you can use that to quickly create a new plane. So we exit that sketch, we go go front plane, and we drag that plane over. Again, you could just drag a plane over there, 65 over 2, but that's not how you would do it if you were actually drawing this up for manufacturing. So I'm going to try and do this the right way. And so now we're going to create some geometry here, and that geometry is going to, ultimately it's going to be patterned. So we do kind of want to think about that idea, but I think we can just create this geometry right from the front plane here. So I could create a line here that starts out kind of above the front plane here, make that at 120. This is kind of larger scale dimensions than what you would typically have in a manufactured part, a machined part. So you might consider getting in here and just creating a reference dimension down to that location at 300. And that way you just kind of help keep this first sketch in proportion. So now we could come down here with a line at an angle, come across here to 20, come up with a line that comes all the way up to there. Whoops, all the way up to there. And then we can create a dimension from the origin, from the center, from the side plane over to here, 200. Pretty easy, that first sketch. That's what it should be. That's all I would do with that first sketch. And then I would just take that geometry, S key extrude, and I would bring that out to a depth of 12. Enter, enter. And then we could take our front plane and our right plane, pick both of them, and then you could go into reference geometry axis. So this would be called main plate, and then this would be called something like axis for pattern. And then we could take the circular pattern command, and we could take our axis here for the pattern, and then we could choose to pattern a body, and the body that we would pattern would be this guy, and we would choose to pattern that into 4 locations. Whoops, I messed this up. I know exactly what I did. I messed this up though. So we could pattern that into 4 locations like so. So that gives us the pattern of that, kind of gives us that shape that we're looking for. But the thing that I messed up here is I forgot that if the center of the axis of that pattern is here, then that's where the origin should be, and that means that this should be over here. Shouldn't be right there. So just a little misstep there as I was creating that first sketch. So I said it didn't matter. You could just make it right on the origin, but really this should not be coincident to the origin there. And some of those dimensions should not be to the origin either. So the dimension here, I go to the top plane. You notice when you dimension, you could pick the top plane. Then you could go to here. Whoops, pick the top plane, create a dimension between those. And then I could go from this line to here. That's going to be that 200 dimension. And then I could go from the origin or from the right plane. Sometimes I pick the planes over to here, and that's going to be that 32.5 or that 65 over 2. Or right click, make that a driven dimension, throw some parentheses on it. That's something that I'll do a lot over here in the this little side panel over here. And then I could take this point of the 65, hold control, that line there, and then make those coincident so that the two are kind of entangled. Because this is going to be like my main layout. And then I could call this like 65x65. I don't usually put dimensions in the names of the features because they're not dynamically linked. So if that dimension changes, it'd be nice if that sketch updated, but it doesn't update the name. So instead I would call it like main layout center square or something like that instead of the actual number. So there we go. You see that fixed it. Move that over. That fixed it. And then we can go in here to our this surface here. Select a face, begin a sketch, orient the view, S key slot, and this slot is going to go from, it's 20 millimeters over, so I'm just going to kind of locate it arbitrarily here, and then we're going to add in our dimensions. So from here to here is 20, and the width of the slot is 25, and the depth to the point of tangency, so you remember hold shift to get the max arc condition. You don't have to, in the old days, you had to click on the dimension and then go over here to leaders. And then down at the bottom of leaders, there was a section that was called arc condition. And you could pick arc condition here and you can switch it. I mean, you can still do this. It still works. Minimum tangency, center of arc, max tangency. But if you remember that you can just hold shift, that saves you time modeling that. S-key extrude, this is going to go through all. And then whenever you're working in multi-body, you have this thing down here called feature scope. And this is where you define what is going to be affected by this. So the way feature scope works is if it's two if statements. If not hidden and if intersected by extrude, then cut. That's basically how it works. So if the body's not hidden and the body is intersected by the cut, then the body will be selected and added to this list. So if I say through all selected bodies auto select and I hit the green check mark, then you'll see that these two bodies are both affected by it. This body is affected, this body is affected. And then if you edit that feature, the cut extrude, the feature scope will now show you that those two bodies have been selected as part of that feature scope. Now, if I control Z, which is undo, and then I go to this body here and I hide it, so hide this body here. Now, if I go S-key extrude cut and I go through all and it's set to auto select, well, that body is not shown. So now when I hit the green check mark and then I show that body again, you'll see that that body was not affected by that cut extrude. So the body has to be shown and the body has to be intersected. This body's not intersected. This body's not intersected. So those bodies are not selected as part of that cut extrude. And this body here was hidden, so it is not affected by that cut extrude. So it has to be intersected by, and it has to be shown. And so when you're doing that cut extrude, if you want to have a little bit more control over what gets affected and what doesn't, then what you can do is you can go into the cut extrude and then you can just uncheck the auto select. So we make this through all, and then you uncheck the auto select, and you could say, I know it's going through both of these, but I only want it to affect this one here on the back. I don't want it to affect this one here on the front. That happens a lot when you're doing multi-body design. So you can do that. You can uncheck that option for auto select, and then that way you can be a little bit more explicit regarding what gets affected by it. So hit the check mark there for that one. Oh yeah, that looks good. And then finally, we go here to this one. Select the face, begin a sketch, orient the view. This is the one that got, I think it was Gray. I think Gray was in this one. This got him really jammed up because he didn't have the correct location on this one. So, you know, for this one, what you could do is, let me hide that plane. You could use the old center line trick. So this is going to come over 32.5, and then it's going to come down 160. And then you could jump into the circle command and then drop in your circle there. And that is at 40. And S-key extrude, right mouse button through all. Auto select is on. It's only intersecting those two. They're both shown. So that should take care of that. Oh, yeah. Then this one would be called something like slot. And this would be called something like lower hole. And Control Q to update the sensor. Control Q. 663.1, and the answer we're looking for here is 663. Yes, 663, and 8 minutes, 11 seconds. A little bit longer on that one. A little bit more lessons on that one, but I hope you guys enjoyed those lessons, and if you did, be sure to hit the like button on this video. Leave me a comment down below. Let me know what you learned. Be sure to interact. Should have referenced the origin. Yeah, I like that. All right. Looking good. Message redacted. I was looking good, but only for a second. Guys, let's keep going. We're going to finish this by 11. That means we got to blast through some of these. If you're enjoying this live stream, be sure to hit the like button, and of course, be sure to sign up for TooTallToby's practice models. It's the place to go to learn how to speed model, how to do some of the stuff, pull off some of the moves that we're doing here. TooTallToby.com, access the full library. A lot of these have, what's it called? Tutorials. People have posted their own tutorials. So if you get stuck, look at this. Crispy Co posted a tutorial here. Shout out to Crispy Co. So if you get stuck, you can watch a tutorial, or you can watch a speed run. A lot of people have posted speed runs too. You get on the speed modeling leaderboard. Get on that speed modeling train. TooTallToby.com. The place to go to practice your CAD skills, refine your CAD edge, and of course, get tons of good community interactivity. If you like the community, You're going to like it over there, TooTallToby. You have lights on in the appearance for Red Oak? I don't think so. I don't think I did anything tricky. I think it's just that scene. I just used that. It's like the second scene down on the list. Make sure everybody can see this. That did not help at all. Make sure everybody can see that. Guys, our next challenge, as we are ripping through this thing, our next challenge is going to be challenge number 2. This is a good one. They're all good ones. If you're enjoying these challenges, be sure to hit the like button. And a lot of people were asking about this one, so I'm very excited that we get to show this now. This next challenge is going to look a little something like this. And if you guys are out there and are interested in learning more about 3D CAD, you can take a screen capture of this so that you too can play along with the vacuum cleaner attachment. This was a fun one. It was an opportunity to show off some pretty cool patterning. Jao is in the chat. What's up, my man? Welcome, welcome. Thanks for joining us. We're going to model every model using SolidWorks. Don't forget to share and reshare. Guys, throw this up on Facebook. If you're in any Facebook groups or Reddit groups or anything like that, throw it up there. Say, hey, this guy's live streaming all these models. These are some good tips and tricks. You guys should tune in. If you're interested in SolidWorks, this will help you guys learn how to use it a little bit better. And just how to be an overall better CAD user. Think through these models. Do the models over and over again. It's a great way to experiment. Okay. That's enough. We're good. All right, everybody. This one is going to look a little something like this. We're going to do a slot for the base. We're going to extrude it up. The base has a different wall thickness than the tube, so we'll probably shell that out at 6 millimeters. Or just... Actually, you know what I think I'm going to do for this one? I'm probably going to extrude this. Just this shape here. Since that has that kind of same wall thickness. And then the tube maybe. Then maybe shell that. And then I'll add the lip on the bottom. And then we'll add the holes. I think that's a good, solid game plan. You guys agree? Hit the I agree button. I don't know if that's an agree or not. Easiest solution was to split the curve-driven pattern in half and mirror. Ooh, I like that. I like that. All right, guys. I hope you guys enjoyed this live solve using SolidWorks. If you do, be sure to hit the like button. Be sure to leave me a comment down below. Share the video. Share it into your text groups, even if it's just your family. You know, let your family, let your parents know what you're doing. Let your kids know what you're doing. The more views we get, the better. This CAD challenge begins in 3, 2, 1, go. What is the mass of this part in XX.x grams? The answer we're looking for is 34.4. You guys like that I'm spoiling these? You think it's too much to spoil it? I don't have to spoil it if you don't want me to do that anymore. Just let me know. I just like to remind myself what I'm looking for the answer. Normally, we'd have the validator on the website, so. All right, here we go. Vacuum cleaner attachment. We're going to bring this over. We're going to bring this up. We're going to add in our dimensions here at 56 and max dimension here. So hold shift, come across to here. 85 max dimension. S key extrude. And we're going to immediately type in the depth of that extrusion at 2.8. I like this one. This is like a 3D printed part. Reverse the direction of that. Right click to finish that. Front plane, begin a sketch, get normal to. This is kind of a weird sketch here because it is defined in an unusual way. The way that these lines are defined is a little bit unorthodox. But again, this is what ends up happening in the real world. You have customers that come to you and they say, these are my requirements. And you have to kind of know how to handle these situations, which is why I like to include challenges like this. So for example, the diameter of this tube up top is 35. The angle is 45. You know, so far so good. That's pretty standard, I think. But then the location of this point here, there's like a max location from the very bottom of the model. So it's going to be, this is going to be a kind of a tricky one at this point. Actually, I'll just draw in that extra depth there because that'll make it a little bit easier. So 9.8, I could do it with an equation, but I could just draw that extra depth in since this is kind of a layout. And I can then extrude up to that vertex. So then that's going to be 66. And then the location to the, where's the other location that I'm missing? Oh, there's like a weird location from this line down to that bottom point on this side. I should have put that 9.8 over here on this side. Make these. Can I make that horizontal? I gotta add it in manually. So it's from this line to that point at the bottom. So weird. Who made this drawing? So weird. So, all right. So now we got that whole, it's basically a layout sketch, but now we got all that geometry laid out. Now that's going to make it really easy for us to create the extrusion. There's a lot of different ways you could do it. I think what I would probably do is just reference geometry plane and then click on this line and click on this point and then right click. That gives us a plane. Pick that plane, begin a sketch, create a circle here, get the midpoint here, get this point here, extrude that circle, double click this surface, right click to finish that one. Then I could take this geometry here and shell it. So shell, remove this, and that's going to shell at 2.8. There's a couple ways I could have done that, but that I think works just fine. And then this surface here, begin a sketch, convert entities. And for this one, I probably would just extrude it and just add in the thin feature right here. I mean, again, there's always so many different ways to do this stuff, but I think this is fine. 6mm wall, and then that's going to go to a depth of 9.8 minus 2.8 because I have to account for the wall thickness, or that could just go up to that reference sketch. That's probably a little bit more elegant. So if I've got that reference sketch there already, then it's probably more elegant to just go edit feature and go up to vertex and then just hit that vertex there from the layout sketch. And now I can add in those fillets. So the fillet here on the outside is radius 5. Click on this edge here, enter, and then enter again to begin the fillet command, and then immediately type 2 for the radius of that other one, and then I can put in that radius fillet here on this edge, and then I can finish up by creating the curve for the curve-driven pattern. So pick this face here, offset entities. That's going to offset to a distance of 3, reverse direction, green check mark, exit that sketch, pick this face, begin a sketch, S key, circle, drop in the circle right here on that the midpoint of that line that I just created. I don't know why I can't wake it up. So that's 3mm diameter hole and midpoint. S key, extrude. That's going to go to a depth of 4. And then go in here to our patterns, and this is going to be curve-driven pattern. And for direction 1, instead of picking this, because it'll only get that line, see, it only gets line 10 at sketch 5. Instead of picking that line, I go over here to the tree and I pick this. So a lot of times when I'm doing a curve-driven pattern, I'll call this one like curve for pattern, so it makes it easier to make that selection when I go into curve-driven pattern. You could also, instead of going over into the tree and picking that curve for pattern to get the whole sketch included, you could also just pre-select it and then pick curve-driven pattern, and it'll drop it in there at the top. That's what I usually do. I just pre-select it. And then for the features, it'll be this cut here. And then for the pattern here, you've got the option when you're creating a curve-driven pattern to define the spacing, so like 10mm between each instance of the pattern. Or you've got the option to do equal spacing. So this one's going to be equal spacing, and then the total instances is 20. And that does include the seed. This is, again, where, doing practice will help you learn what to expect from future applications of the same tool. So starting with the seed, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So what did we learn? We learned that it's 19 copies plus 1 original. So when you type in 20 here, that's not the number of copies, it's the total number of instances. That's good to know in the future if I want to use curve-driven pattern again. So curve-driven pattern like so, and boom, we can hit the green check mark. Now, the other thing that we could do with this curve-driven pattern is we could use the option here. So you pick this face, begin a sketch, convert the outer edge. So now you see the curves going around the outer edge. And then we go to curve-driven pattern. So let's say we pick that as our curve, and we go to curve-driven pattern. And then we pick the cut extrude as our feature to pattern. And you'll notice here that this one, there's this option here for transform curve and offset curve. And that's kind of an important option to recognize. Hold on, let me change my background color to make this a little easier to see. So go in here to my scene, and I'll make this like just like a darker background there. So if we take this and then do curve-driven pattern, you can see here that you've got this option for transform curve and offset curve. And what that option does is it either looks at where the curve was relative to the original hole and then creates the pattern based on that relative location. So you see how like it's taking that pattern and it's just offsetting it it's offsetting it down here because that's the same offset as was originally there. It's like taking the whole curve and just transforming the whole curve down. Or you can let SOLIDWORKS recognize what the offset was from that curve to the original instance. And so that's what this option here, offset curve, does. So it's really good to learn how those different options work. You can get some kind of different results from curve-driven pattern depending on which of those options you use. On a similar note, you can also get some different options depending on the geometry that you're patterning based on the option for align to seed. So for curve-driven pattern here, let's say that the pattern that I'm creating looks like this instead. So extrude cut, depth of 4, and now we're going to take that and we're going to pattern it along that outer curve. So curve-driven pattern here. So you can also get some different results here from. Oh, let me change the part color. We're just changing everything here. So if we take this and then we do curve-driven pattern, there's also the option for align to seed versus tangent to curve. So this will sometimes come up if you do align to seed, then all those rectangles are vertical. All those rectangles are vertical. If you do tangent to curve, then SOLIDWORKS analyzes what the tangency or what the rotational orientation is of the original, and then it recognizes how that rotation is changing as the curve changes. So you've got this option here, align to seed versus tangent to curve, which will affect your results. You've got this option here, transform curve versus offset curve, which will affect your results as well. In the instance that I did, the curve was running right through the center of the hole, so it would be moot. We wouldn't really get any difference. But it's good to know you'll sometimes run into this when you're using that curve-driven pattern, and that's something that you can benefit from if you know how each of those work. The final one down here, face normal, that comes into play if you're doing a 3D sketch as your curve line. If you're following a curve along a 3D sketch, like one time I was creating a kind of a complex drilling tool for a company, so I was doing a 3D sketch with a curve pattern, and that face normal becomes a tool that you would use in that scenario to try to help with the alignment along 3D space instead of just 2D space. So it doesn't really come up that often, but there are times where you could learn how to use that if you were doing more complex geometry. So again, in our scenario, the curve has been offset, and the curve is going right through the center of our model. So it does kind of become moot because this is going right through, and it's a circle. So like rotational adjustment doesn't really come into play, and it's going right through the center, so it doesn't really matter. But it's kind of cool to know about if you ever get into using the curve-driven pattern, which is a good tool to know how to use. Okay, and we hit the green check mark, and boom, 34.4 is our answer. 34.4 is our answer, and our time was 9 minutes and 50 seconds. Not that fast. We probably could have done that one a little faster. One more concept I just want to bring up here about curve-driven pattern that's kind of good to know, a little bit thinking out of the box. And I know that linear pattern does now offer tools to kind of calculate end conditions, offset from end, things like that. But when it comes to doing curve-driven pattern, kind of like a thinking outside the box scenario you could do is you could just use a curve-driven pattern to create a linear pattern at a set spacing. So if the customer came to you and said, like, I want to create a series of holes and I want them to start from this side offset at 17 millimeters and I want it to end at this side offset at a distance of 34 millimeters. So kind of like a weird, unusual, or 33 millimeters, kind of like a weird, unusual spacing. Well, what you could do is you could just create a sketch that represents where they want those holes, and then use that sketch as the alignment tool for a curve-driven pattern. So if the customer said, like, I want this series of holes and I want them to be located in these locations, like, based on some type of linear offset, well, you could then do a curve-driven pattern, and you could say, this is my curve for the pattern, and these are my features to be patterned, and I want there to be 5 holes. So it's true that you can do stuff like that in the linear pattern command now, but this is kind of like a really nice, easier way. I see Matab, this is resonating with Matab in the chat. So Matab is saying, I used to do a lot of maths for stuff like that. And yeah, you can definitely do it with math. You can do it with equations. You can do it with offsets. But sometimes it's easier to visualize and change and work with your customer if you just like drop in a line and then say, okay, there's my curve-driven pattern, right? A curve can be a line. A lot of times we use the term line and curve interchangeably in one direction. So if we say, like, you're going to pierce this arc or this point with a curve, you could pick a line representing that curve. Usually it doesn't go the other way. You don't like say curve if you mean line, but you could say curve as like a catch-all. All right, guys, if you like that one, hit the like button. Be sure to subscribe. Be sure to sign up for Practice Models and Practice Models Premium. Support the channel. It's a fantastic way to support the channel to win-win. You get to get better at CAD, and we appreciate the business when people upgrade to Practice Models Premium. I think that brings us back to the Wheel of Fate for another challenge. Here we go. Got a couple more here. I don't know if we're going to make our 11 o'clock deadline, but we sure are going to try. Let's do one. Okay, listen, whatever model comes up from the wheel this time, I'm going to do it super fast. I'm just going to blast through. I'm going to turn up the music, and we're just going to rip through and do a speed run. Now, some of these are still bombs. Some of the bombs are still out there, so hopefully it's a quick one. Good luck, everyone, and good luck me. Fully Defined coming in with some Australian dollars. Thank you, my friend. Bedtime now. I learned some things tonight. Cheers to all. Don't forget to always fully define. Yes, fully define every time. Thank you, thank you, thank you, my friend. Thank you for the super chat as well. Zhao says it's only 4:30. We got a lot of time before 11. Okay, that's good. Thank you. All right, number 13. Ooh, the drafted box. This is one that Matab won. Let's go. All right, this is a good one. This is one that we can definitely speed model. I'm going to bring up the drawing here. I'm going to just step away for a second. Nature is calling. I'm squirming a little bit. So if you guys want to follow along with, take a screen capture, and I'm going to take just a quick break. All right, and we're back. Perfect timing. All right, I hope that was enough time for you to grab that screen capture. People are asking when we're going to be done. We're going to be done when we get through all of these, but hopefully it'll be, in about 25 minutes. We're shooting to finish in the next 25 minutes. That means we're going to have to really speed through some of these, and this is a good one to speed through, the drafted box. It's a good model, good real-world exercise. You know, one of the things people say about the TooTallToby website is that they really appreciate that the challenges are real-world challenges. You know, that they're actual models that you would see in the real world. It's not just like a widget. I mean, some of the lower tier stuff is kind of just widgets, but I try to keep as much of this stuff real-worldy as I can, certainly during the tournament. I just think it's such a great way to learn CAD. So, yes, we are still showing the website. That is correct. Showing the website, not the model drawing. Yeah, the model drawing was up a second ago, right? We're good. We got this. I hope I'm not doing this wrong. Vicky always keeps me in line. All right. This is great. I missed the first 30 minutes, and I'm going to be home in 20 minutes. Oh, don't worry. We'll keep going for you, FPV Kev. Don't drive distracted. He's gonna get pulled over, and they're gonna be like, "What are you watching? A CAD live stream?" Okay. All right, guys. This one's in inches. Here we go. Here we go. This next CAD challenge begins in 3, 2, 1, go. All right, what is the mass of this part in pounds? We got one in inches and pounds, and this is in ABS inches. And this one is going to start on the top plane. I think that's pretty obvious. And it is 5 by 7, and then this gets extruded. And after we extrude this, we're going to apply some draft. So 1.5. I guess we could just apply the draft while we're extruding. 8 degrees draft per side. Reverse direction. And yeah, I like it. This is kind of a tricky one because it's, you see these radii here, it says radius 0.750, not conical. So we want to make sure that we put those on after the extrusion is done, not before. If you have those fillets on there first and then you draft, or after the draft, I should say. If you have those fillets on there first and then you draft, that's going to be problematic. And that radius is radius 0.75. And then we add another fillet here. I could have used that enter trick. Radius 0.5. I remember, I think Matab missed that fillet during the tournament. If you guys go back and watch the tournament, you'll see what I'm talking about. 0.225, is that what the wall is? Yeah, 2.5 for the wall. Just remove that top face there. And then we have our geometry that starts out at the very top. So like something like this, I might, I probably would just sketch it down here, and that way I can extrude it up to that dimension. Makes it just a little bit cleaner, I think. The diameter is at the top. So it's a 2-inch diameter at the top, and then I could do extrude and reverse direction and bring that up to those 2 inches. I guess I could also do the extrude as an offset. So here where it says extrude from, I could say I want to extrude that from an offset of 2 inches, and let's reverse the direction of that offset. And then I could say I want this to go up to body and pick this body here. And what that would do for me is it would allow me to extrude this with draft outward as I'm creating the extrusion. So it might just be a little bit more elegant to do it that way, or at least a little bit less features in the tree. I don't know. Like for me, I kind of like having the draft feature in the tree as its own feature, but that certainly is an option as well. And so now I think at this point, what I would do is I would create a new plane offset from the top down here. So pick that face, S key reference geometry. S key reference geometry plane. And then that offset is going to be 0. Oh, it's from the bottom. S key reference geometry plane, and that is 1.25 from the bottom. And let's flip that offset, and that gives us our plane for ribs. Plane for ribs. And then in this plane for ribs, I think Matab, when he did this, he did one rib and did a circular pattern, which I thought was so sick. But that is definitely not how I would do it. I would have just done it like this. Just draw a line here. Draw a line here. Remember, if you use the click and drag, you just make one line at a time. Draw a line here, draw a line here, and then jump into the rib command. So features, rib, normal to, and wall thickness at the top, I think. Is it at the top or at the bottom? Wall thickness at the top, 0.250. And then this has draft of 8 degrees per side, right? Same draft on the ribs. Yeah, 8 degrees per side. And the rib command will, reverse direction, flip material side. There we go. The rib command will let us get all 4 of those. No, not letting me get all 4 of those. Why? Because of the draft? What? Wow. If I was in the tournament right now, I would be like, what? That's not fair. That's not right. Doesn't work, it says. Doesn't work. Do I have to? Wow. All right, so that's all right. We can do some troubleshooting here. So if I was troubleshooting this, what I would do is I would start with a little divide and conquer. So I would make these for construction, and then I would try it again. I would try to keep it as simple as possible. So I would just kind of like little by little rip this thing out. Okay, so that worked. So it worked for just the 2. And then for this one, it worked for the 3. And then for this one, back into that sketch. For this one, okay, it worked for all 4. So the problem is not with the rib. So is it with the wall thickness? So it works with the wall thickness. So it's not with the wall. So is it with the draft? So if we make the draft here 8, it's not with the draft either. The problem is that it just didn't work the first time. Just SolidWorks being SolidWorks. Cool. Yeah, take that, Matab. that makes total sense, right? Like, what? And that's how we troubleshoot in SolidWorks. We get the customer on the phone. The customer calls us and they say, it doesn't work. And then we just do it like that. And we're like, it works fine. And then the customer is like, wait, I know I did it the right way. And we know. We know that it is quirky like that. I don't know why, but it is quirky like that. All right. And this one is going to have a diameter of 1.5. And we're going to extrude that with draft. And that draft is going to be at 8 degrees as well. And that one's going to go through all. We're right back on track here. There we go. And let's take a look at the sensor. And the sensor is coming up with 0.754. And that is correct. 0.754. And 6 minutes and 3.5 seconds. Nice, nice, nice. All right. Guys, 61 people watching. If you guys are enjoying this live stream, hit the like button, put a 1 in the chat. Let me know that you're out there. Say hello. Let us know where you're watching from. GG number 5. We only did 5 so far. Oh man, we got to pick up the pace. I know I'm going to just keep saying that. I'm going to keep looking at the clock and I'm going to keep saying, we got to pick up the pace. And then I'll probably just keep going the same speed and explaining all these little bonus tips and tricks. Like the character map. Guys, if you're out there and you want to learn more about 3D CAD and learn how to be a 3D CAD wizard, visit us at TooTallToby.com. We've got a library of 2D to 3D challenges, very similar to what you're seeing here. Look at this library. And these are all nice, fully defined drawings. They give you all the dimensions you need, and they give you a chance to practice your CAD skills using any 3D CAD package and practice against the clock. It is a good time and a great way to learn 3D CAD efficiency tips and tricks and learn how to practice your workflows. You know, a lot of these workflows that I'm doing, I know what's going to happen in the software. Usually, I didn't know what was going to happen with that rib, but usually I know what's going to happen with the software. I'm able to predict it, and the reason why is just because I've done the reps, I've put in the time, and that's a great website you could go to put in the reps. Our next challenge is going to feature a very special model. Model number 1. Yo, let's go. This model was inspired by our friends over at MacroPad. So you can check them out, macropad.io. They create totally customizable and customized macro pads for all of you. This is drawing number 1. If you guys want to challenge me, if you want to see if you're faster than me, you can take a screen capture of this drawing. You can start kind of planning out what your approach would be for a model like this. And we're going to get started here in just a moment. You versus the CSWE, the wizard, the whiz kid. So can you model this part faster than Toby? That should have been the name of this live stream today. Can you model faster than Toby? Why are there ever any Creo users in the tournament? Jel Van Loo asking a fantastic question. Yeah, we see a lot of comments about Creo users. We see a lot of comments about NX users and Solid Edge users. Guys, the tournament is open to one and all. You guys are all welcome to enter. I would love to see Creo users. I would love to see NX users. I would love to see Solid Edge users. Let's go. The tournament's open to everybody. Watch this video. See see how you stack up. Okay, and you can watch some of the tournament videos too and see how you stack up, and then we can get you in there. But registration is open. The World Championship is coming up. And if you visit us at TooTallToby.com/tournaments, the World Championship of 3D CAD Speed Modeling is open, and you can click here to qualify for free. And we got some wizards in there that are already running this leaderboard. So you could definitely join us on this leaderboard. Creo users, welcome. Solid Edge users, welcome. NX users, welcome. All CAD are welcome. All you got to do is get in here on this leaderboard, model these 3 parts, and boom, you're in. Top 16 are going to qualify for the World Championship. All CAD are welcome. All right, guys. Well, welcome to this next challenge. We're going to try and model up this part. If you want to model it up, if you want to see if you are faster than me, take a screen capture of this print. We're going to get into this modeling challenge here. in. Let me move this over here to the side. We're going to reset the clock. The correct answer for this one is, what is it? 100.7. You're listening to 100.7, the greatest in synthwave radio. Here we go. This CAD challenge begins in 3, 2, 1, go. What is the mass of this part in XXX.X grams? This is one that I think we would start from the top. Aluminum 1060, MMGS, top plane, begin a sketch, orient the view, S key, rectangle, single click, move your mouse, single click is going to be 88 miles an hour, 116, and then S key extrude, and that's going to come up to a height of 20 millimeters. And once again, this would be a model where I would absolutely use the fillet radius shortcut tools. This thing has a radius of 9 in all 4 corners, so I would just rip this corner here and then use that fillet kind of auto radius tool. We're going to shell this thing now. This is going to shell to a depth of, what's the wall thickness? 3. And we just remove this back face here. And now we're ready to get in there and start adding in the, I would probably add in these things first. I was calling them standoffs for screws. That's what they are, right? Standoff for the screw. And the standoff for the screw is at 70 by 98, but that's also concentric here to this. If you look at the math, it is concentric there. So I would probably just make it concentric there. So that's going to be concentric, and that thing has a diameter of 6 millimeters at the top, and then it gets extruded with an outward draft of 4 millimeters per side, 8 millimeters total, and that's just going to go up to surface. So we just double click this surface here. You notice that when you double click, you 2x here, double click, it changes this from blind to up to surface. One of the best shortcuts in SolidWorks. So now we can pick this face here, begin a sketch, S key, circle, drop in a circle there that has a diameter of 3 and a depth of 10. So extrude 10, enter, enter. And now we can take those features and this plane and mirror them. And something that I always do is I customize this context menu to add the features command mirror to this context menu, because then when you hold control, you pick these features and that plane, the mirror command just shows up, so you can just press enter and then move on to the next. So we pick these guys here, pick mirror, enter, and move on. Look how fast we're able to get those mirrors in there. That's what's up, baby. If you guys like that one, put an M in the chat for mirror. We love the mirror. And then for this final pattern here, all we really need to do is just make that 18 by 18 hole there. So 18 by 18. And then this is going to have some fillets on it. I probably would put the fillets here in the sketch just to make it a little bit easier to pattern. So this is going to be a sketch fillet at 2. And remember, when you're in a sketch and you're doing a fillet, you can just do a window select around all the geometry and it gets all 4 corners. So you see there, it just gets all 4 corners. It doesn't give me any error messages or anything, just gets me all 4 corners. Gets a little bit chaotic with regards to how many relationships are on screen, but it is good to know that you can just kind of window select to get that geometry. This is going to be 9 off of this side. It's going to be 14 off of this side. S key, extrude cut, right click through all, right click, and then we can take that shape and we can do a linear pattern, and direction 1 is going to be this direction, direction 2 is going to be this direction. We'll reverse direction 1 and we'll change that to a spacing of 18, and number of instances would be 5 there. Whoops, looks like that spacing is going to be, I think I made my rectangle the wrong size. And then direction 2, the spacing is going to be 18 and the number of instances is going to be 4. Let's reverse the direction on that and hit the green check mark. And we'll just say all bodies for now, and then we'll go back into that cut extrude. I think I made that 18 instead of 16. There we go. Control Q, and our sensor says 100.7, 100.7, and boom, 339. Thank you very much. Thank you very much. 339 is the time for that model. If you're trying to finish all these models by 11 o'clock, then you're going to need to up your pace. And that is the super fast build of that model. FPV Kev, great to see you here. That was a fun one. We like that one. GG number 6. Let's go. 339. Beat it. You guys are out there. It's up to all of you to beat it. Here we go. Let's keep going. Now we're getting into the groove here. Don't forget, if you guys are out there and enjoying watching all these models, visit us at TooTallToby.com. Sign up for an account. Get started for free today. And sign up for Practice Models Premium to unlock the entire library. Here we go. We're going to try and model through the rest of these. Oh boy. We got model number 9. This is one that we have been wondering about. We were wondering when this one would come up. And now it is here. And of course, model number 9 is the one-line cube. Kind of looks like a corporate logo. It's a fun model for sure. Guys, if you want to model this along with me, see if you're faster than the CSWE, the expert, then you can join us here. And here is what that drawing looks like, the one-line cube drawing. There it is. And take a look, grab a screen capture. You can model along with me once I start the clock. It's kind of a fun thing we're doing in today's live stream. And don't forget, if you want to really refine your skills, visit us at TooTallToby.com. Sign up for a free account today, and then you can sign up for Practice Models Premium to unlock the entire library. We've got over 200 CAD challenges of real-world parts. What better way to learn than by doing? Oh yeah, it's time. Want to see the approach so badly. Matab, there are so many different ways to approach this model. I wasn't even sure how I was going to do it. And I decided I'm going to do one with, well, you'll see. Don't want to spoil it. Here we go, guys. This CAD Speed Modeling Challenge featuring the one-line cube. Such a fun model. Such a cool model here. We're going to try and come up with the answer. 205.4. It was Gray who won this one in a heated battle between Gray and Sebastian. Really cool model. Not too many dimensions you have to remember, but really cool model. Here we go, guys. This one begins in 3, 2, 1, go. So what is the mass of this part? It is in 1060 aluminum, MMGS. Let's go. And I'm just going to go front plane, begin a sketch. And I'm not going to worry too much about the origin for this one. I think what I'm going to do with this one is I'm just going to go from this lower corner here and create something at 60, whoops, by 60. 60 by 60. And then I'm going to extrude that out to a depth of 80. And so what I'm going to do here is I'm going to kind of carve out this shape. I'm going to kind of carve out this shape right here. Just carve out this shape, and then I'm going to use some patterning stuff to get this all into the right spot. So to carve out that shape, I'm going to create a fillet here, like so. That fillet is going to have a radius of 20. That's kind of like the outer fillet there. And then I'm going to create an extrude cut here at 20 by 20. And we'll do extrude cut, and we'll rip that through all. And then I'm going to, actually, you know what? I think in the original one, I think what I'm going to do is, I think I'm going to create this a little bit different. I'm going to create this as an offset. So offset that to 80, and then reverse direction here and make that one 10. There we go. Okay, and then add that little fillet on there. And then for my cut extrude, we'll just do edit sketch plane. Make sure we get that on that plane there. Just bring this guy over here. I don't know why that would be a problem. The whole thing, it's that whole polarity thing. That's really what it is. The whole polarity thing we talked about earlier. And then we're going to take this this shape here. We could shell this shape maybe. Like just shell it out here, get rid of these guys, and just shell it at 10. Like that gives us that shape there. You can see where the origin is. The origin's still back here. And then what we could do is we could take this shape here, and we could do a 10 by 10 rectangle there, and we could do a 10 by 10 rectangle here. And then we could take that shape and we could extrude that out to the depth of this direction here. Like basically whatever the depth is, it gets us into this corner here. So that depth is going to be 60, I think. I think that goes out to 60. Like so. And then we could do a body copy. So we could do insert features, move copy, and we could just make a copy of this. Now, the copy that we create of this could be, so we're gonna come all the way down here to the bottom to where it says translate rotate, so that it's just doing like a Boolean copy. And then when you make the copy, you could put the copy wherever you want. I think it's probably helpful just to kind of put it out in space. And so we could just kind of drop the copy in there like so. So now I've got 3 bodies on this thing. And then we could use what are essentially mates at the feature level, we could use mates at the feature level. And even though you're in a feature level, it's almost like you're doing an assembly. You're assembling these components here at the feature level. And so what those mates might look like would be something like this. We could go insert features, move copy. So you've inserted one body into another body. And then here, instead of translate rotate, you switch this back to constraints. So you say you want to take this body here and you want to move it. And the place that you want to move it to is such that this face here is coincident to this face here. And we want to flip the alignment on that one. So flip that mate alignment like so. And then we say add, and then we could create another mate here that says that maybe this face here is coincident to this face down here. And again, flip the mate alignment. Okay, and we say add, and then we can create another mate that says this face here is coincident to this face here. So it's kind of like if you're used to working in assembly mode, you might actually prefer to do something like this where you're kind of like mating multiple bodies together, and it gives us a chance to see a different approach. I know that in the Discord there were a lot of people that were doing like splits down the middle here and then mirroring. So this is just kind of like a different approach where you can actually mate different bodies together. So if you insert one part into another part, you could kind of use this technique as well. So insert features, move copy. And then once again, we're going to kind of align this thing up. So like this face here, this body, and then this face here would be aligned to this face down here. And we'll flip the mate alignment on that one and add. And then this face here would be aligned to this face here and flip the mate alignment and add. And then this face here would be aligned to this face here and add, and done with that one. And then all we should need to do is just a quick Boolean combine here. So select all three of these, right click, combine. So this is another kind of cool shortcut. You could go insert features, combine. But if you pick one body and then right click, you don't get combine. But if you hold control and then right click, you do get combine in this menu. So if you pick multiple bodies, so a lot of times when I have like 50 bodies, I'll just pick one, hold shift, pick the bottom one, right click, combine those bodies together, and control Q. 205.4, and that is correct. 205.4. Oh yeah. 5 minutes 47 seconds. Let's go, let's go, let's go. So that's kind of a cool one. I like that one. It's a fun model. It's like a corporate logo. It's a square. You know, the dimensions on this thing, it's a cube. The dimensions are really simple on this thing. It's just 80 by 80 by 80. But it's a real like brain melter when you're getting in there and trying to model it. And there's so many different ways that you can model it. It's such a fun model. And it's all one piece. This would be kind of a cool 3D print as well. It's all one continuous piece. So there you go. The one line, what's it called? One line cube. The one line cube. If you guys enjoyed that one, hit the like button. Mates at the part level. Yep, you can insert. Because remember, you could always do insert part into part. So you could always do insert part into part, and then you could browse your library for a part. So like this is the library of TooTallToby practice models here. So I could add one part to another part. Okay, and then you've got this part in here. Now you've got these two different bodies in here. Now I need to locate them relative to one another. So, you know, normally you go insert features, move copy, and then you just do like a straight Boolean copy using translate rotate. So you'd pick this and you'd move it over here and then like kind of move it over here. And you got to like type in all these numbers and everything. But if you realize that you could also use the option for constraints, then you can just put this exactly where you want it. So you'd say like, I need this face to be right up against this face here. Boom. Mates at the part level, the multi-body part level. Insert part into part. Okay, guys, if you enjoyed that one, hit the like button. Be sure to like, be sure to subscribe. And we're going to continue on our journey to complete every tournament model. That was a pretty cool one. Let's go back to the wheel. Only a few left. I think we're going to be done by 11. Oh, it's already after 11. That's all right. We're going to be done sometime. We still got the bombs in this thing, the huge ones. So I got a feeling they're coming up soon. Okay, this is a good one. Number 11. The fixture block. Nice, easy one here. This is a nice, easy one. It's like the wheel knows that everybody wants to see. The wheel knows what everybody wants to see. And so the wheel is holding them off until last. So, guys, this one is a really fun one. You guys can take a screen capture here and you can model it right along with me. Let me bring this up here. Number 11. Fixture block. Matab made short work of this one during the tournament. Matab says, I've never seen a live stream for 2 hours continuously. Yeah. This is a good one. We're getting some good stuff in here. Guys, thank you so much for tuning in. Don't forget to hit the like button. Don't forget, if you want to learn how to use some of these skills, visit us at TooTallToby.com. Sign up for practice models. Learn by doing, right? That's a great way to learn. If you're trying to learn 3D CAD, you can start out at the very bottom level, the tier 1 challenges. They are very easy, and then you can kind of build your way up. Start at the beginning. Matab says he could have done this one faster using an L shape. Yeah, I probably would have done it with an L shape as well. But look, man, you won. You won that battle. So can't argue with results. All right. Let's go. Oops. Get rid of this one. Guys, don't forget. Welcome. Good luck on modeling this. You can model this against me. You versus a certified SolidWorks expert who can model faster. And don't forget that if you want to get a ton of CAD practice, if you're learning CAD or if you're an existing pro, visit us at TooTallToby.com. You can start out with some free challenges here. You can sort by tier level 1, so you can do some really simple models. Look how simple some of these models are, right? This one here, very simple. Just a little simple L shape here. Piece of cake, right? It's a tier 1 model. But once you get your skills down, you could upgrade, maybe get up to tier 3, tier 4. This is a pretty fun one here. This wheel. We always like doing this one, the wheel. These are all challenges that you can do at TooTallToby.com. You can see what the average completion time is, and you can challenge yourself to model even faster than the average from the field. TooTallToby.com, sign up today. And guys, this next challenge is going to be the fixture block. The answer to this one is 90.4. We're going for 90.4 on this one. This is a tier 3 model. Most of the models we've been doing have been higher level complexity, but this is just a tier 3 model. So this one should be a little bit on the easier side. Pretty straightforward how to model this thing. Zhao has to go. Says, see you tomorrow. Yes, see you tomorrow, my friend, for the finals. Cannot wait. It's going to be so good. All right, guys, here we go. This CAD modeling challenge begins in 3, 2, 1, go. What is the mass of this part? It's 1060 aluminum. Lots of 1060 aluminum parts in this tournament that have been selected by the wheel. Front plane S key, begin to sketch. We're going to get over here. We're going to turn this into 60 by 24. Come over in this direction by 11. Come down in this direction by 24 minus 9. Come over in this direction to just above the origin. Come down here to close this thing off. S key, extrude. And this is going to come out to a depth of 42. What a magic number. Pick this face, begin a sketch, orient the view, S key, create a rectangle here. This rectangle is going to have a distance of 5 by 14 and an offset from this side of 14 as well. This is a spot where we could add in those fillets using a sketch fillet just because it's very easy to window select these points. Love doing that. And we can also drop in the circle here up top. That circle has a diameter of 12 or a radius of 6. And the distance to the center of that circle is 21, which does happen to be the middle of the part. S key, extrude, right click, through all, right click. And now we can come around to this side here, pick this face, begin to sketch, orient the view. And of course, it is always helpful to learn how to create a tombstone shape when you're sketching. So I could single click here. Actually, let me start at the bottom here. Single click here, move up, type in the height to the center of that arc, 30. Come back, hold my mouse over the endpoint, come up and around, type in the radius of that arc, which is a radius of 12. Make sure that I'm getting horizontal to that endpoint of that line and then close that thing off. And that is how you can fully define a tombstone in one pass. Here you can see we can type in the depth of this thing, which is a depth of 14. We can right click and reverse direction on that thing. And then we can finish off by adding in our counter bore here, S key, whole wizard. And this is going to be a counter bore at the dimensions of 10 tab, 18 tab. And the counter bore depth is 4 tab. And then position here, wake up the center point, and drop in that counter bore right there. Final feature fillet here goes on this edge with a radius of 4. Enter that edge right there. Enter. Bring up the sensor. Control Q. 90.4. Type it in. 90.4. And whoa. Wait a second. That happened to be the correct answer. Oh my goodness. Wow, that was crazy. Guys, 90.4 is correct. And I guess it is correct also for this particular model, which is just like the simulation is running out of RAM type of a scenario. Wow, 90.4 is correct. And it happened to be 90.4 for that model as well. That was totally by random coincidence. Yes. Wow, what a coincidence. Exactly. 90.4 is correct. 2 minutes, 29 seconds. How did you guys do? Let me know in the comments. Let me know in the chat. Were you able to model it faster? How fast did you model it? And of course, if you want to visit us at TooTallToby.com, you can model against some of these other amazing models that we've got here in the library. All right, let's get the timer up and running again. That was a cool one. That was a nice, easy one. Little warm up there. Warming us up for the challenges that we know are coming soon from the wheel. If you guys haven't been there before, visit us at TooTallToby. We've got a library of exciting real-world CAD challenges similar to what we're doing today. And let's give this wheel a spin. Matav says, I beat you by 20 seconds. Yeah, but you had never seen the drawing before. I had seen the drawing, so that makes your time like 10 times more impressive. Because to be able just to look at that drawing and then come up with a game plan right away, that is so cool that you guys can do that. I think it's awesome. So fun to watch the tournament. Guys, if you're around tomorrow, the tournament is live streaming tomorrow at 1 o'clock East Coast. Matav versus Gray in the finals. James versus Sebastian in the warm-up match. It's going to be good. Okay, and speaking of warm-up, this is another fun kind of a warm-up model here. Model number 12. So let me remove that one. We'll turn off the wheel here. And if you're out there watching and you want to challenge me and see if you can model it faster than me, well, then you can check out this drawing here, drawing number 12. You can take a screen capture and you can begin modeling it once I begin modeling it. This is the dual alignment tool. It's kind of a cool model. It's got a little bit of asymmetry on it. It's always fun when these models come in that are non-symmetric. A lot of our models in the world of TooTallToby are symmetric. So I like it when we mix it up a little bit and have a model with no symmetry. So let's give this thing a go. Don't forget to hit the like button. Don't forget to subscribe to the channel. Share this live stream with other people. And of course, if you're watching a video recording, leave me a comment down below. Those comments are very helpful for engagement. All right, hope that was enough time to grab a screen capture. Now it's you versus me. Who can model this part fastest? Some tricky dimensions in this one. Here we go. Let's bring up our CAD system. We're going to be using SolidWorks for this one. Let's bring up the clock. And, oops, the clock got a little bit different. Here we go. This CAD challenge begins in 3, 2, 1, go. What is the mass of this part in XXXX grams? And this part is in plain carbon steel. Yo, I like it. So again, this part's asymmetric. I think we're just going to start here on the top plane, kind of looking down from the top. Maybe we would opt to create this the way that it's shown there on the print, which would be to, usually what I'll do is I'll put my corners here at the origin. The thing about this part that's a little bit tricky is that it's dimensioned from the center point of these radii. So it's something where I would probably just kind of like eyeball it up for the general shape, add in the fillets, and then kind of lock everything down. So there are 16 radius 16 fillets here on the 4 corners. So using the trick that we've been using for the past couple models, I would probably just window select and get all 4 of them. And then I would go through and start locking in all the geometry. So the dimension from this center to this center is 70. The dimension from this center to this center is 80. From this center to this center is 80. The dimension from this center to this center is 100. And S key extrude and bring that up to a height of 15 millimeters. 15, enter, enter. And then what we've got is we've got the shape that's kind of like going through the middle. Like we'll just call it the 2 shapes for lack of better description of this thing. So I would probably start here on this side, S key reference geometry plane. You know, again, we are speed modeling, but we still want to follow best practices. And if you have a plane there for your coworkers to look at later, it's going to just make their life easier. It's going to make your life easier. So this would be called offset to tombstone shape. And then we could use that plane to create that tombstone shape. So S key, again, using the tombstone workflow that we talked about a moment ago. So pick this face here, go up to 70. That's the center of your tombstone. Come back, touch the endpoint, come up and around. Input what the radius of that is. So radius 23. So now you've got the radius in there. Single click horizontal to that end line point and come across. And now you've basically got a fully defined tombstone. All you need to do is define the location. So the location from the back edge of the part to here is a distance of 51. And that's it. Nice fully defined shape. That's what we want when we are working in SolidWorks, fully defined geometry. We can see that the diameter of the hole in the tombstone is 30. I would probably just include that right there in that sketch and just get them both at once, save me having to go back in and add that in as a secondary. And that's going to be at a wall thickness of 15 as well. So now we just kind of rinse and repeat on this side. Pick this face S key reference geometry plane. That's going to offset to a distance of 12. Flip the offset so it's going inward. And this time we can reference the geometry from the other shape because it is an alignment tool. It is an alignment bracket. So what I mean by that is I could take this shape here and either convert it, or I could just create a circle here concentric right out to that edge. This is probably what I would opt to do because then I can just use a rectangle here for the width of that lower section. So the width of that lower section is 28 or 14 per side. So I could make that lower section there, 28 in that lower section or 14 per side. And so meant to do that with the smart dimension, whatever. I'll just go with what's in the drawing, 14 per side here. Oh, I reattached my dimension by accident. Totally inadvertent there. And then we could take this line here, make it collinear to the edge of the model there, collinear, and we could take this point here and make it midpoint. Oh no, we don't need to make it midpoint. We just need to make it coincident there so it's locked up at the top. So there we go. That gives us all the dimensions that the customer was asking for. We could also add in a circle here for that one. That diameter is going to be 25 on that side. And then just extrude that all using the contour selection tools. So extrude, contour, 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 reverse direction, hit the green check mark. And now the only thing that's left to do is to add in that rib shape. The rib shape does have draft, and it looks like it's got a wall thickness specified at the top. So for this one, what we could do is we could create a new reference geometry plane in either scenario, but probably in a spot like this, what I would do is I would show this sketch here and then go to the front plane, hold control, drag the front plane, and then left click on this point and then right click to finish the command, because that gives me a plane that's running right through the center of that geometry and directly at that point there. And so then I could use that plane to begin a sketch and then create the sketch of the line for my rib. And then all I need to do is just add in the locating height for that rib. So 42 from the bottom here for that rib. And then I can take that rib and I can go features, rib. This time it's going to be parallel to the sketch plane. The wall thickness at the top of the rib is going to be 8 millimeters at the top of the rib. And then the rib has this draft on it. And the draft here is going to be at a draft angle of 8 degrees per side. Now you'll notice here that in the definition of the rib, you can specify what the wall thickness is, and once you kick on draft, you get these two options here. So is that wall thickness where you created the sketch line, or is that wall thickness where the rib actually hits the wall, meaning hits this lower surface down here? So that's kind of cool that you can define that. Let's hit the check mark and then quickly confirm that we got the correct dimensions. So when I pick this edge, hold control, pick this edge, and then look down here in my status bar, the total distance is 8. And when I pick this edge here and I pick this edge here, and then go down and look at my status bar, the total distance is 15.59. And the person who made the drawing was nice enough to let us kind of use that as a double checking tool. The rib should be 15.59 at the bottom. So boom, that all looks correct. Do the final spin. The whole model looks like it is missing these counter bores here. So pick this face here, hole wizard, and the counter bores are called out at a value of 12 tab, 20 tab, 8 tab, and positions. And then we'll just wake up the center points for these 4 locations. 1, 2, 3. Wake up that center point. 4. Wake up that center point. And Control Q, and in our center here, 2, 1, 1, 6. Looking at my answer key here. 2116, and that is correct. 2116, and that is correct. Oh, yeah. 635. Not bad. Not bad for a tier 4 part with some complex geometry in it. Peekaboo looking for his 12-month. He won. I guess he won on one of our giveaways. Vicky's in the chat. Yep, she's going to be able to help you out with that. Exactly. We probably just lost the message in transit. I know we reached out to all the people who won in that last tournament. She's going to figure out what happened. There we go. That is nice. Good job. Thank you, team. All right, guys. We're winding down here. This has been a fun live stream. Hope you guys have been enjoying this. Put a 1 in the chat. Let me know that you're still out there. I appreciate everybody being here with me, rolling with me through this. And now we are going to take a look at our final batch of challenges. And the Wheel of Fate is always a sweetheart and has held on to some of the most difficult models for this moment. Remaining still in the list is the wood grill, which is kind of a cool like speaker grill. The circular grill top, which we saw last week. The hex hot pad, and I think there's a sheet metal model in here too. Yeah, the SM dual slot bracket. So we got some good ones in here still, I think. But I don't see the SM dual slot bracket in here. That was 12. Guess we don't have that one on the list. Sorry, SM dual slot bracket. We missed you. Wait, do we have one in here that shouldn't be in here? Wood grill, dual alignment tool. We just did dual alignment. Oh, we just did 6. Were we supposed to do... Did I do the wrong one there? Maybe this one was supposed to be... Yeah, that I think there was just a mix up there. I think that one was supposed to be 12. Yeah. Okay, there we go. All right. There we go. It's fixed. Shuffle, 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 shuffle. Okay, so remaining, we have the sheet metal, the SM dual slot bracket. Remaining, we have the circular grill top. Remaining, we have the hex hot pad. And remaining, we have the wood grill. So we got 4 really good ones still. A lot of them with patterns. And I cannot wait to do this one. So, Akalesh is asking a question: how to participate in the quiz. So you can participate by just by being here, and being a part of it. You can participate, meaning that you can just challenge yourself and see if you can solve these models right along with me. You can see if you can finish them faster than me. That is a nice, easy way to go through and do this. You can just try to solve them right along with me. The other thing that you can do is you can sorry, I'm trying to fix this overlay here. You can also visit us at TooTallToby.com. If you visit us at TooTallToby.com, you're going to see that there is a library, a repository of these quizzes. So you can do these quizzes here. You can sign up for free. You can filter this list by free, get started for free. We've got like 10 or 15 models in there that are free for everyone. You can start out at tier level 1 if you're just getting started in 3D CAD, or if you've got some more experience, you could go up to tier 2, tier 3, tier 4. You can see that we've got a lot of free challenges for people. And then if you really like the app, if you're really getting a lot out of the app, you can sign up for our premium offering, where we've got a library of over 200 of these 2D to 3D CAD challenges. So basically, once you sign up, what you can do is you can click into one of these challenges. And when you click into one of these challenges, you could say reveal drawing, and you can try to model this part up, and then you can enter the mass over here in the chat. So you could enter in the mass 999, enter. Nope, that was incorrect. And so you can keep trying until you get it correct. And so it's just a great opportunity for you to practice doing 3D CAD with real world models, with models that are fully defined, fully constrained. And there's some really fun challenges in here. Some of these challenges you can 3D print. Some of them are woodworking type projects. And it's just a great way to learn CAD. Of course, if you ever get stuck... oh, he says those drawings are too easy. Okay. Oh, I see how it is. So there's a filter here that you can use where you can take a look. You can see that there are some more challenging drawings in here for you. And so you can filter this by maybe like tier 4, tier 5. If you're ready for the higher level challenges, you could definitely give it a shot on some of these higher level challenges. Like this one here. This is a pretty good one. A nice sheet metal stand for a phone. This is actually a physical part that we have here. sheet metal stand for phone. Some of these models can be 3D printed as well. So you can get in here and you can challenge yourself to maybe some higher level challenges. If you're pro level at Akalesh, yep, you're welcome. Thank you for joining us. This is a good one here. This nice tier 6 challenge here. Some of these tier 6 challenges might be more your speed. This one here was a nice fan favorite. It's like a assembly, one of those IKEA style shelves with multiple shelves and tubing and bracketry. And this is a really a fun one here that you can try to go through. Nice tier 6 challenge here. So check it out. But for those of you that are just getting into the world of CAD or just looking to kind of like mix it up a little bit, like maybe you do sheet metal brackets all day, you do all sheet metal. Well, maybe then instead you'd want to look at like some of the swoopy lofty challenges or some of the 3D printable challenges. You know, if you're doing the same thing at work all day, it's kind of nice to have. It's almost like a gym for your CAD brain where you can go and you can kind of mix it up a little bit and try out some new types of geometry that you don't normally do. And then a lot of times what happens is you learn like, oh, wow, I do sheet metal all day. I never use drafted features, but there's actually some spots where I could use a drafted feature to create kind of the foundation for sheet metal. And then I'll use convert to sheet metal to turn that into like a, you know, an oven hood or something like that. So it's pretty cool. You know, you can use what you learn here in some of these other areas, other skills back in your daily job. And of course, most importantly, you've got the ability to do the challenge and then do the challenge again and then do the challenge again using the try again functionality. So in our featured models up top, you can use this try again functionality at will. And so then you could try to create this model, and then if you get if you get it right, but then you're asking yourself like, well, would it make more sense to do this as a sketch pattern or do it as a feature pattern or maybe do it as a mirror at the end? Well, you could kind of try out all those different workflows and, figure out which one works best for you. You could even try the same model using different CAD packages. A lot of times people like that. So a lot of times people like doing that because then they can, experiment with different CAD packages and kind of see which one is faster. Sean Richard says you should add your best times to the web app so you let us know we were faster than you. Yeah, exactly. Well, what we've got there, Sean, that's a great idea. What we do have is we have the speed modeling leaderboard here. So for each one of these challenges, if you scroll down, you can see here that we've got people who are logging in and they're putting in their best times and they're actually including a video. So anytime you complete a challenge, your time gets logged, and there's a list here of the top 100. So the top 100 times here, the fastest times from the time somebody pressed start and then pressed finish. But the thing is, like, if you've already done the challenge once, then you know the answer. So you could just go try again, reveal drawing, type in the answer, boom, done. And then you're going to have a 2-second time. So what we've also got is the ability not only to show that you're one of the fastest users, like MCGA here, one of the fastest users in our community did it in 32 seconds, but you've also got the ability to prove that to the community by posting a speed run of that model. So you can see here that you could actually click on these videos and you can see here what MC, how the heck did this guy do this in 32 seconds? Like, that doesn't even seem possible. So here he is modeling this using CATIA, modeling up this part, and it's not, he didn't speed up the clock or speed up the video or anything like that. He actually modeled this whole thing, applied the appropriate material, got all the dimensions correct, and he proved it. He proved it by posting a video. So this is pretty cool stuff here. And I'm certainly in here as well. Toby, I go in there and I post a lot of, I post more tutorials than I post speed run videos. But wow, there you can see he did it. He's so fast. He's definitely one of the fastest in the communities. I go in here a lot and I post videos, but I post more tutorials. So like if you click into this challenge here, this is one of the first challenges. This is where people kind of tend to get started. So if you get stuck, I post tutorial videos to help people kind of get unstuck as they're going through and they're doing the challenges. And these are community tutorials. Anybody from the community can post a tutorial in here. It doesn't just have to be me, but I do post some speed runs in here. I did that one in 46 seconds. You can see Matab in the chat did it faster than me. He did it in 35 seconds. And some of these guys did this even faster, 17 seconds. But this is a pretty simple model. This is just a simple tier 1 model. It's not, you know, it's not really that crazy what's going on with this particular drawing. But it's meant to be like an intro for people that are just getting into CAD. So, you know, you have to think about things like, even on a simple model like this, where should the origin be located? You know, a brand new user will probably put the origin just in some random location in space, where an experienced user would say like, okay, I'm going to put the origin down here in the lower left corner because it makes it easier for me to dimension the different features. And so, you know, everybody has to start somewhere. And so that's where the tutorials are nice, because I really go through and explain, you know, like the foundations of not only like how to sketch a line, but why you would put the origin in a certain spot. Why should you extrude mid-plane versus, you know, extruding blind in one direction? So there's a great community here of people that are also making and contributing these tutorials. When you finish with a model, you can go down in here and then you can upload your tutorial. So there's a great community of people in here that are posting tutorials. And like I said, there's also a nice leaderboard here too, so you can kind of see who's the fastest. All right, guys, thank you for letting me talk about practice models. We're really proud of this app. We've been developing it for a long time. We're always adding in new features. Do we have a community Discord? Absolutely. Yeah, we absolutely have a community Discord. So if you do go in here to the Practice Models app, the link to the community Discord is right up here. You don't have to be logged in or anything. The link's just right here, and that'll take you right to the Discord. I think we have like 1,100 people in the Discord now. So we got a great community. Anytime somebody gets stuck or has a question, you can definitely get in there and ask questions in there too. And if you like this kind of stuff, please consider supporting. You can sign up for a premium membership. The premium membership is, you can see what the prices are here. So it's $9 a month or $7 a month or $6 a month or $5.83, depending on what if you buy it for 1 month, 6 months, or 12 months, and that will unlock the entire library. So after you get done with your free challenges, you can unlock the entire library. We're trying to drive traffic, Matab. That's why we're saying it there. Get people into it. We want people to see the Practice Models app. We want them to go and visit the site. All right, guys, that was a nice little intermission. Let's get into these beefy final challenges. Here we go. These are some of the most difficult models that we've seen in the tournament. And today is your chance to see if you've got what it takes to outmodel TooTallToby. This next challenge is model number 18, and this was an absolute crusher in the brain space. Model number 18 is, of course, the Hex Hot Pad. So this is a very, very fun challenge here. Here we go. This is what it looks like. If you guys want to take a screen capture, you can take a screen capture and you can try to model this right along with me. This comes from our CAD vs. CAD tournament, which concludes tomorrow. If you want to tune in tomorrow, you're going to see Matab versus Gray in the finals, and you're going to see James versus Sebastian in the warm-up. But here you can see this is a very tricky model. It is the Hex Hot Pad and a very fun model. This is one that was actually inspired by conversations that were taking place in the Discord. So because of the conversations we were having in the Discord, we decided to create this model and include this model as a challenge. You can see this is a tier 6 model. Tier 6. Let's go. And this is a fun one. So take a screen capture so that you can practice right along with me, so you can challenge yourself, see if you're faster than the CSWE expert. The presentation today is a little bit of a mix of tutorial / just straight speed running. I'm not necessarily explaining every step the way I would in a tutorial, but I hope you're still finding it helpful. If I did explain every step, we'd probably be here until 11 o'clock Zhao time in Belgium. I think he's in Belgium. All right, guys, here we go. We are ready. Put this up top. Get rid of the wheel. Don't forget to like and subscribe. Leave me a comment down below. Let us know what you think about these live streams. Jern says there's such a variety of CAD packages in the Discord as well. Yeah, it's absolutely true. Such a cool environment. I love the idea that, like, we don't have to be in silos. You know, it doesn't matter what CAD system you're using. We can all learn from each other. There's some foundational things we should all be doing. And you can learn. You can learn by watching the way somebody else works in their CAD system. And there's been so many times where I've been watching an Onshape or learning an Onshape. You know, I'm really learning Onshape a lot these days. And there's been so many times where I've learned something in Onshape and been like, oh, I wonder if I can do that in SolidWorks. And I've gone back into SolidWorks and learned, like, yeah, you definitely can. Like, one example of that was the... let me see if I can't remember if I saved this model or not. Oh, yeah, I did. Cool. One example of that was this model here, and the use of the 3D sketch for Hole Wizard. I don't know if you noticed that, Matab, or if you already knew that, but you know, in Onshape, what we do is we use the mate connector to center the holes on these four edges all at the same time. Like we get all 4 of the holes at the same time. Well, in SolidWorks, you can do that. So if you go Hole Wizard and then you go simple hole, I think these were 9mm for diameter for these holes. Then what you can do is when you go to positions, instead of picking this face, which will put you into a 2D sketch, you click this button here for 3D sketch. So now I'm in a 3D sketch, but you can still wake up the center of that arc on that face, even though you're in 3D sketch, and you can still do it over here as well. So that's something that I learned by spending time in Onshape and learning how it worked in Onshape, and then going back into SolidWorks and being like, oh, that's pretty cool. Wow, I didn't think you could do that. That's pretty epic. So it's a really cool idea here of like watching other people in other CAD systems and learning the way they do things, and then kind of taking it back to your CAD system and saying, oh, you can actually do it there too. All right. And Sean is saying GPT came up with an answer for this one. Yeah, I wonder if it modeled it, or if it might have like scrubbed the what's it called, the audio transcript from YouTube, because I do announce the correct answer. So GPT might have been able to scrub that, and then like if you typed in this model number, I don't know if you showed it a picture or if you typed in the model number. It will be interesting when GPTs are able to just like take this drawing and turn it into a model. And that'll definitely, like, that time is coming. It's probably already here, honestly. There's probably some people that are already doing it. But the thing is, like, you don't get models like this from customers, especially in like the initial inception phase. So like the model you're going to get from a customer is going to be like this, and like nothing is going to be proportional. And they're going to be like, yeah, put a hole through here, and then put some countersinks here, you know, and you're going to have to look at that and then turn that napkin sketch into a 3D model. So it's still very much valuable for you to learn how to do these skills, and especially in 3D printing, like learning how to, you know, just kind of sketch up and use that geometry and to like retrofit something into the real world. The skills we're learning here are so valuable. Matab in the chat saying that was new. Yeah, that is good. I showed it a picture. Oh, that's cool. All right, cool. Then I will not reveal the answer either. I will wait until the end and let you know if I got it correct. So here we go, guys. Good luck if you want to model against a wizard, a certified SolidWorks expert. This is your chance. See who's faster. This CAD challenge begins in 3, 2, 1, go. So the question here is, what is the mass of this part in xxx.x grams? And this is made out of ABS in millimeters. So new part here in mmgs, and we are speed modeling, not tutorialing. So let's go. Let's do this. So top plane, begin to sketch, and this is going to be at 185 by 204, and S key extrude, and we'll bring this up to a height of 8 millimeters, and S key fillet. And the fillet's going to have a radius of 15, and we'll pick this edge here and then pick all 4 edges at the same time. And top plane, begin to sketch, and S key circle, and we'll drop in a circle here at a diameter of 28 and S key dimension. And this is going to be to this location here at 44 and this location here at 34. I probably should have put that on that top surface instead of the top plane, but through all and reverse direction. There we go. And then S key shell. I don't know why I don't have shell on there. I need to put it on there. Shell. And this is going to be shelled at a wall thickness of 4 millimeters. Let me think here. Did I do that right? I think that circle should have been 20. And that way, this outer edge here will be 28. Yeah. Okay. And now that's it for the first half of this model, kind of phase one. Phase one, let's get that thing all ready to go and then get ready to accept phase two. So phase two, we're going to create a hex here, and we're going to do it as a body, and then we're going to pattern the body. We're going to do some body patterns, baby. Could probably do it as a feature pattern too, but I'm going to do it as a body pattern. So I'll pick this face here, begin a sketch, orient my view, S key, nope, hex, drop in a hex here. This is going to be inscribed, and let's change the color of this model again, make it a little easier to see. And we're gonna, this is gonna be an inscribed circle of 32. And then this is going to be horizontal or vertical. And then it gives us a little hint on this drawing. It says, hint, locate this one first. So that's because, you know, in the real world, they're not going to tell you that. They're just going to tell you to make it look good. But we needed to have this thing be accurate so we can measure whether or not these guys were getting it right. So what we're going to do here is we're going to extrude this as a thin feature. We're going to apply a wall thickness here of 2 millimeters, and we're going to extrude it to a depth of 4 millimeters. And we're going to say that we want that to be not merged. So don't merge the results. So now you can see that we've got a total of 2 bodies in here. So the shell and then this extrude thin one. And then what we could do is we could hide the shell for now. We can, you know, click on it to bring it up if we want to see what the boundary of the shell looks like. But the reason that we're doing that is because it's going to make it a little bit easier for us to do some merging when we create this pattern. Now, the other thing that we're going to do here is we're going to create a line that goes from the center point here over to this location right here, I think. Let me think, is that right? Or is it going to go to, we're going to account for the, we'll figure it out. I don't know if we have to account for the wall thickness or not, but we'll go over to that location there, and you can see that that was 16 was the length of that line there. So when I click on that line, if we look down here in the, if we look down here, we can see that that length is 16 millimeters. So that's going to be an important number for us to remember, because now what we're going to do is we're going to create a pattern of this. So we'll do a linear pattern here. For direction 1, we could just pick maybe like a line from that original model, or you can even pick the top plane so that the pattern goes perpendicular to the plane. And then for direction 2, we're going to show that sketch, and we're going to pick this line here in that sketch for our direction 2. Now, really what I think I would probably do here is I would probably save that pattern for a secondary pattern, just because of how this thing has to fit into that other shape. So maybe for direction 2, we will also pick the right plane here and have it just kind of go in the other direction. Or maybe this would be a good spot to actually show that original. See, this is where a lot of times I do a lot of work in this sketch here to kind of just like leverage the layout capabilities. Because then when I go to create my patterns, I can just select these entities here. Okay, that's just like a personal preference, but you guys might find that tip helpful at some point. So linear pattern, direction 1 will be this direction, direction 2 will be this direction. And then for my pattern, I'm going to do bodies to pattern. So bodies to pattern is going to be this body here. And then for my distance here, for direction 1, I'll make my distance 16. And actually, no, it's going to be 30. 34. Hold on, direction 2. Let's set that down so we can kind of see what's going on with direction 1. There we go. So for my distance there, I'll make that distance 34 so that that side wall lines up perfectly. And then when you go to do direction 2, what you have to remember is that by default, what a pattern is going to do is it's going to take all these instances of the pattern and then it's going to pattern them again in the second direction. So if direction 2 was this line here, for example, and then we increase the number of instances here, what we'll see is that direction 2 is creating a pattern of the pattern. Well, that works okay in this circumstance where you're creating a grid, but you want to remember that if you're going in 2 different directions outward, you want to check this option here for pattern seed only, because otherwise you're going to take this whole pattern and pattern it this way, and then you're going to get duplicate copies of it going back in this direction, and that can sometimes yield unexpected results, especially when you're doing like a derived pattern or something like that. So for direction 2, we want to make sure we choose pattern seed only, and then the direction 2 will be this line here. And if I just like view the preview of that other body, there we go. That's what we want. Whoops, we want to go one more instance in direction 1. So we just view the preview of that other body so we can see everything. And then we can do another pattern here. So we're going to take linear pattern, and we're going to go direction 1 is going to be in this direction. Direction 2 is going to be in this direction. So just use those lines that we created. And then the features to pattern will be the original hex and the linear pattern. Whoops, sorry, not features to pattern. The bodies to pattern is going to be all these bodies. So just window select there to get all those bodies, and that makes short work of that. You hold your mouse over the original so you can kind of like dial in what the pattern instances should be. So this one could be a little bit shorter. It doesn't have to be perfect as long as you're like overcoming the overall pattern. If you looked down here in this region and you realized that you needed to go back and add another one from the original linear pattern, you could go back and do that. But it looks like we've got enough to cover the entire pad there. So we hit the green check mark, and this is going to create a million patterns, right? Both pattern directions are parallel to avoid performance, do you want to use the option pattern seed only? That's kind of nice that it warns you about that. So do you want to proceed? No. Let's make sure we use that so we don't get all those additional instances. That would have been a performance nightmare. And then we can just take all of that and just merge it. So what I'm doing here is I'm picking the first one, and this is a great shortcut. You hold shift and then you pick the last one. And then you let go and then right click and then combine. So that was kind of hidden down there at the bottom. Let me start at the bottom and I'll go up to the top. So I'll pick this bottom one, go all the way up to the top, hold shift, pick this top one, let go, right click, and then you do combine, and then you hit the green check mark, and boom, that combines it all together into one body, so you're going to get the better performance again. And now we can just show this, and we can begin a sketch here, and just take this geometry here, maybe just like take this face, and do a convert entities, take this edge here, do a convert entities, and then S key, extrude cut, and this is going to be through all in both directions, and it's going to be flip side to cut, because if we cut it right now, we're going to lose, what's going on the inside, so we end up with this, not quite what we want. So when you do that cut extrude, you're going to do flip side to cut, so that's going to kind of inverse what gets cut away. Okay, and then for this cut extrude here, we would want to only include the, not include the shell, only include the combine. So that comes back to something we talked about earlier, your feature scope here. So the feature scope originally looked like this. Originally, it looked like this. It had the shell and the combine as what's being cut by the feature, the scope of what's being cut by the feature. So we're going to say, don't cut this, and hit the green check mark, and that only cuts that. And then we can finish up here with the final combine. Combine, green check mark, and the answer that we are coming up with is 180.8 grams. And that is correct. 180.8, and that is correct. 9 minutes and 12 seconds. Guys, how did we do? How did we do? Let's go, let's go, let's go. Could do it with a fill pattern. Yep, I like that. Fill pattern would work there too. I like that idea of doing a fill pattern. But it's kind of a cool example of working with bodies. We like the idea of working with multi-body. And generally speaking, whenever I've had to do weird patterns like this that go across other weird shapes, that's how I do it. I always end up at this point where I've got like a grid of the thing in what's going to be its final state. And then I either do a combine or I do an overlap, like whatever's common, or I do some kind of a Boolean command to rip out or combine the bodies together. ChatGPT was way off. 239.8. Nice. We still need humans. Yes, good. I love humans and I love human music. All right, guys. That's it for that one. I hope you guys enjoyed that one. If you did, be sure to hit the like button. Leave me a comment down below. Let me know how you modeled that part up. And we are going to continue with our live stream. Don't forget, if you're ever looking for more practice, some good real-world examples going from 2D to 3D CAD against the clock, what better way to learn than by practicing, by doing it yourself? TooTallToby.com is the website. And that's going to take us into our final 3 models. And let's see what the Wheel of Fate has in store for us. These are all the models that we've seen in the tournament, which concludes tomorrow. Tournament concludes tomorrow. All right, and we're going back. We're going back a bit to model number 5. Drawing number 5. So during the tournament, what we do is we show these models, these challenges, these drawings to our CAD experts that are in the tournament, and they attempt to model these on the fly in front of all of us. Here on the website, what you can do is you can access our library of challenges, and you can take a look at one of these challenges, and you could try to model it up yourself. You can see here are all these different challenges. We have so many challenges in here. You could find one in here that works for you, and then you could try to model it up yourself. What happens is when you try to model these challenges, we show you a drawing and a clock, and then you try to turn that drawing into a 3D model and calculate the correct mass based on that material and material density. And of course, here today, what we're doing is we are taking these drawings, and I'll show you guys a copy of this drawing. This is a pretty fun one. This one is called Wood Grill, drawing number 5. we take this drawing here and we're going to try to turn it into a model and calculate the mass correctly. So if you're out there and you want to get some CAD practice in on this beautiful Thursday, you can attempt to model this with me. I'll include the clock and I will attempt to model it. And you can see if you're faster than me, a certified SolidWorks expert. And we're going to try to model through this part. This is kind of a cool one, a wood green. You could use Very Sketch on this one. I don't think it's really necessary. I think you could do this one. Honestly, you could just do it with a pattern because the default behavior of a pattern is that it's going to pattern up to surface for all the subsequent instances or up to next for all the subsequent instances. So you could probably just do it with that. I think I'm probably going to end up doing it with that. So I'll probably just model half of this thing and use a pattern with Very Sketch, or with Very Sketch. Sorry, with the dynamic end condition rebuilding for every instance. But Very Sketch is definitely, an option. Could definitely use that here. Just not necessary. I don't use that when it's not necessary. I don't mess around with that when it's not necessary. All right, guys, here we go. I hope you guys are enjoying this live stream. We're winding down to the final 3 models. This model number is drawing number 05. We've been using all these drawings in our tournaments for the past couple of weeks, and tomorrow we will see our finals. If you want to tune into the finals, join us tomorrow for the tournament. The live stream's at 1 p.m. East Coast. And I think that for this model, what I'm going to do is I'm going to draw half of it. I'm going to draw one of these extrusions and rip it up to this wall, and then I'll create a pattern, because by default, when you do a pattern, the end condition is retained for the pattern. And then I'll just do a mirror the whole thing over to this side, basically like a mirror body. Mirror it all over that side, and that should make short work of this thing. Let's give it a go and see how it goes. Here we go. Flip over to our CAD versus CAD screen. You versus me. CAD versus CAD, you versus me. And this challenge begins. Whoops, let's bring up our CAD system. We're going to do this one in SolidWorks. This challenge begins in 3, 2, 1, go! What is the mass of this part in x.xx pounds? So this one's made of red oak and it is in pounds. And we're going to go front plane, begin a sketch, orient our view, and we're going to stick with our game plan, which is to create this kind of shape coming across here, and we're just going to create half of the shape. So let's create our tombstone. Always good to learn how to create these tombstones. Make this one midpoint. We're going to create a center line here so that we can still create our double dimensions, just because it makes it a little bit easier to visualize what's going on. So for example, from center to center on this thing is going to be 6.25. The height of this thing is going to be 7. And that's it for that. S-key extrude. That's going to go out to a total depth of 4 inches. Let's reverse the direction on that. And then this is going to be shelled once we get that out there to those 4 inches. So we'll do a shell here, remove these 3 faces, and that shell is going to be at a wall thickness of 0.5 for the majority of this thing. But on the back side here, there's a little slot shape. So I'll just take these 3 edges here and do a convert, and then I'll do an extrude cut with thin feature. So the thin feature here is going to be at a wall thickness of 0.25. Let's bring that to the inside and bring this to a depth of 1 inch. Bring that to the inside. Okay, and that gives us that little area that gets more narrow on the back of this thing. And now we can begin to sketch on this face here. Get normal 2. We're going to create a rectangle with a wall thickness of 0, or a height here of 0.5 and a wall thickness of 0.375. And then this is going to be offset into the body here at a distance of 0.375. Whoops, this wall thickness is 0.25. Mixed up my dimensions there. And then this thing starts from it just starts in the center. So we can just drop this thing right in the center. Again, the thing you want to remember here is that we've got we're going to be creating a pattern. So it may be beneficial to draw 1 or 2 additional lines that you could use as part of that pattern. You could draw them in an arbitrary location, or you could hook them onto the origin. Either way, it might make it a little bit easier. Of course, we've also got edges we could use for that pattern. Extrude, double click on this face to extrude up to surface. We're going to show that sketch so that we can use that sketch for the pattern. And then we're going to create that pattern, linear pattern in direction 1 and also in direction 2. The direction 2 is going to be pattern seed only, like we talked about in the last example. The spacing between is 0.875. It's nice that they included that on the drawing. Whoever made this drawing is so nice. And then the features to pattern is this thing here. Direction 2 is going to go in the other direction, and this is going to be 4 instances in each direction, I believe. And there we go. And then we can pick that entire body, pick this plane, use our little context toolbar to create the body pattern there, and go into our sensor and rebuild 1.379 pounds. 1.37 pounds. Oh, I missed a fillet. It's off. We're off. That is incorrect. Okay, and then we add the fillet there, and that fillet is 0.25. Enter, and let's rebuild 1.37 pounds, and that is correct. So 1.37, and that is correct. 1.37. 3 minutes and 24 seconds. Yes, we like that one. Fillets. That was so satisfying. Thank you, thank you, thank you. Thank you, my friend. Aziz says, I would have drawn everything in one view and just extruded everything in 3 extrusions. That works too. That definitely works. That's the cool thing about TooTallToby's practice models app, is that you can try it using different workflows. Like you could do it using one workflow, see how fast you did it, and then you could do it using another workflow, and it will track all of your previous runs. So you're able to like really test out those what if scenarios. So you could say like, oh, when I did it all with one sketch, it took me 1:47. When I did it with multiple features, I thought it was going to take longer, but it actually only took me 1:08. Now, obviously, this is a little bit skewed because now you already know the dimensions on the model, but this is kind of assuming that like, you know, you've done the model enough times that is mitigated, that the familiarity with the model is mitigated. So, yeah, it's great to know that there are different ways to create the same model. And that's another spot where TooTallToby's practice models app can be very helpful. So, guys, I hope you enjoyed that one. That was a fun one. Thanks to Matab for reminding me about the pattern, the way the pattern would work. And, yeah, I like that one. I like the way that pattern worked out there. Guys, if you enjoyed that, hit the like button on this video. Leave me a comment down below. Let me know what you thought about that. Let me know if you learned anything from it. And now we are going to move on in the live stream to our final 2 models. We've done it. We've come down the home stretch here, and these are both great models. One of them is a sheet metal model. It's not super hard, but it's always fun to do sheet metal. And one of them is an ultra hard multi-body circular grill top. So let's see which one we get here. Welcome to this CAD challenge. We're going to try and model every model from the live stream. And it looks like the first one we get is going to be the circular grill. Let's go, the circular grill. And so this is a really fun one here, model number 16. In fact, you know what? I think usually I let the Wheel of Fate just have its way, and I am going to do that. But I think that I've done enough sheet metal, especially recently. I've done a lot of sheet metal, so I think this is going to be our last one. I think this is a good way to end it on model number 16. So we are going to forego the sheet metal. It actually wasn't on the Wheel of Fate earlier. So maybe that was the Wheel of Fate telling me that it didn't really want me to do that sheet metal one. So we're going to forego the sheet metal one, and we're just going to do number 16 here. This is a really, really fun model. You guys are in for a treat here to kind of end the live stream today. And let me bring up that 2D drawing so you can see it. And I'm going to just step away from the computer for just a minute so you can take a screen capture of this. Get yourself pumped up for this one, and then we're gonna model this thing up here in just a minute. Nice swampy synth track as well. Yeah, exactly. That's what we like. That's what we like. Okay, guys. Hope that was enough time for you to grab a screen capture, because we are going to model up one of the funnest models from the tournament. Really one of the funnest models from the tournament to date. XATXE Taxifly says, always appreciate your plays. Thank you, my friend. I know I discovered somebody new here. You can look him up on YouTube. KMoney1986. He has got some fantastic synthwave tracks that he's built, and he hasn't posted in a couple of years. But check out KMoney1986. Leave some comments. Let him know that TooTallToby sent you, and you will not be disappointed. There's some outstanding stuff in there. Race Day is one of my favorite tracks, period. No qualification on that, just favorite tracks, period. So check it out. It is awesome. Awesome channel. Great synth. Get you studying, get you productive for sure. And that's where we are now, getting studying, getting productive. Here we go. How do we create this model here? So, I mean, for a model like this, I think that we saw a lot of the runners kind of took a similar approach where they created the geometry in 3 phases, essentially. And I think that's probably how I would do this too. So phase 1, create this ring here on the outside. Phase 2 would be to create the just straight horizontal crossbars. And then phase 3 would be to get into this section here where you've got these 4 feet that are sticking down. So I think that's a great approach. I think the only question is, how do you actually do one of these things? How do you actually model up something like this? And one thing that you want to remember, and I'm not going to do it this way, but I just want to kind of share this with you just to give you some food for thought. One thing that you want to remember is that when it comes to creating geometry that is round bar stock, you can always cheat a little bit by creating the geometry as sharp-edged geometry. So, for example, if we've got this original OD and it was 252, and then I think the wall thickness on these is like 6 millimeters. So we go 6 millimeters, reverse direction here, like so. You could always cheat a little bit by just extruding that geometry as solid geometry with sharp edges. So when it's bar stock, this is a good thing to remember because it might make it easier for you to work with this geometry later. So you could always, kind of get away with doing something like that. And there's your bar stock, extrude it as sharp. And so an example of kind of getting away with something later might be to show this original geometry here to create a new plane at the top of this thing, tangent up top here on this thing, so that we can create our next set of geometry. So begin to sketch here. And then we create our bar stock that's running across in this direction. And then what we could do is we could maybe do something like create an arc here. And we could say that this arc is supposed to be co-radial to this region here. I like this track too. And then we've got our first cross member here, and then we can extrude that to our height of 6 millimeters. And this is going to be a non-merged result because we're doing kind of like a multi-body here. So we can extrude that up to 6. And then we could maybe try to do a linear pattern with our very sketch option. So, we talked about very sketch earlier a little bit. We talked about how maybe you could use very sketch. So we could show this here. Let's see if it works. So we could show this sketch and then say this is the direction of the pattern. And then this is the feature to pattern. And then let's see if we use very sketch, if it ends up. Oh, you know what? I'm sorry. I need to put a dimension in there. I always forget that with very sketch, you have to use a dimension to define the direction. So then if we go linear pattern, direction 1 is going to be from this feature. So you click up here in direction 1 and then click on this dimension here. And then if you say very sketch. So you see what's happening here is that when you want to create a pattern of a feature and you want to use the option for very sketch, you have to click on the feature first. So you click on the feature to pattern. That puts the feature to pattern in this box here. Once you click on the feature to pattern, then for the direction, you click on a dimension, and that dimension only shows up if you click on the feature first. Then that brings up the dimension. And then when you pick a dimension from that sketch, then you can come down here and you can choose this option that says Vary Sketch. And then you can choose this option here for full preview to see if it's going to work. And so you can see that what Vary Sketch does is it takes the original co-radial relationship and it reapplies it on all the subsequent instances of the pattern. So then when we're done with the pattern, we end up with that reapplication of that Vary Sketch, which is pretty cool. I wonder if we could do before the pattern. I wonder if we could fill it and then pattern the fillet as well in that same pattern. So we could basically like get those cuts as part of that pattern. So if we pick the fillet as well, yeah. See, I was worried it wouldn't let you do that. So unfortunately, because you can't fill it in the same multiple bodies in the same fillet command. So for example, if I pick this body here and then try to pick this body, it says edges from multiple bodies cannot be filleted in a single feature. Well, because of that, then what you would want to do is you'd want to use that trick that I showed you earlier, which is you can press enter to finish a command, and then you can press enter to repeat a command, and then you could pick this one and use the fillet option, enter, this one, fillet option, enter, and like so on and so on down the chain. So yeah, Matab's saying, yeah, this is very unorthodox. Yeah, this is definitely an unorthodox approach, but it's just kind of cool. It's like, you were talking about using very, what is it called? Very Sketch. So like, that's an example of how Very Sketch could work. And the nice thing about that is that then if you have more, additional instances, you get to continue to take advantage of that Very Sketch. And then all you have to do is just redo the fillet, pick one, pick this shortcut here, enter. So kind of cool. Little bit of a cool way to kind of end this live stream talking about some different ways to approach this thing. But I don't think that's how I'm going to approach it. I think I'm just going to kind of play it straight, if you will. I would maybe consider doing this one as an extrusion and then add the fillets, just because it's like so much more intuitive to work on that sketch from the top down, rather than like creating a circle here and then creating a center line and then creating a dimension to the tangency point of the circle. Like, it just feels so awkward to do it that way. So I actually probably will create the ring using this technique of the extrude a solid and then add the fillets. But then I'll probably do the rest as like regular, circular extrusions and then cut the whole thing off at the end. It's also nice because then you can reuse the sketch to cut it off at the end. So it's kind of like a bonus, extra bonus there. So let's see how it goes. Let's see if we can actually, apply some of those ideas and get this thing done. And this will be our final speed run of the day. So I hope you guys have enjoyed this live stream. If you're watching the standalone video, I hope that you'll give me a like, give me a subscribe, and visit us at TooTallToby.com so that you can sign up for our Practice Models app and you can practice challenges like this against the clock. What better way to learn CAD than by doing? You can practice doing these models. You can practice against the clock, and you can get started for free. We've got like 10 or 15 challenges in here that are free. You can start out on tier level 1 and then build your way up tier 2, tier 3, tier 4, and ultimately to a tier 6 challenge like the one that we are seeing on the screen right now. So here we go, guys. Good luck on this model. This model is our final model of the day. Hope I didn't lose it. Here it is. The final model that we're going to be doing today in this live stream. And let's bring up a new song to get started here. Let's do this one. Yeah, let's go. We're gonna crank the volume a little on this one. Here we go. In 3, 2, 1, go. What is the mass of this part in x66 grams? In plain carbon steel. So a little trick I used there was to get the spacing correct. I did that as 25 plus 6. And that should give me the spacing of 25 millimeters between the instances. Now, you can always check that real quickly just by dropping in a line here. Just kind of like looking at the auto dimension that shows up from that line. It does look like I got the spacing correct. This is something that happens in manufacturing drawings a lot. They give you the in-between spacing, but not necessarily the spacing. So what you do is you just take, with a circle, with a rod like this, you just take that spacing and then add the diameter, because that gives you 3 additional per side. So 25 plus 6 for that one. So now to get to this geometry here, I think, it's kind of like a hack, but probably like a real easy way to do this is I would just begin a new sketch on this face. So begin a new sketch here, and then I would just drop a point right here on that location, right at the center of that. And then I would exit that sketch, and then I would delete this body. So insert features, delete, keep body. Insert features, delete, keep body. Or to shortcut to delete, keep body, you just find that body over here in the list. So this body here, click it in the list underneath folder, solid body folder, and then press delete on your keyboard, and that shortcuts you to the delete, keep body feature command. So you're adding a new feature to the tree, which is deleting that body. It's the same as insert features, delete, keep body. But instead of having to go into the menu and find it, you can just get it right from there. And so the reason I did that was because now I can go to the right plane, hold control and drag, and then make a copy of this bar right here. So right on that point. And then I can pick that location, begin a sketch. And now I've already got a point right here that's exactly at the right height for the center of this sweep that I'm going to create. So now I can start bringing that point over, and then I could come back, touch the end point, come off. That's going to have a radius of 6. 6 on the inside, so 6 plus 3 actually, because it's this is a center line, so it's going to be a radius of 9. And then I'm going to come down here at an angle, get that tangency relationship, come back, touch the end point. This is going to come around. This is also going to be a radius of 9 because it's to the center, so it's 6 plus 3. So kind of come back here to this location, come up at an angle. Okay, come back, touch the end point, come around here, 6 plus 3. So again, that radius is going to be 9. And then we're going to come across here like so. And then we just need to crossing select that to make those tangent. Whoops, didn't work. So I'll just click the point there, make those tangent, click this line and this line, hold control, make those collinear, and then take this point and the origin and make those vertical. So that way it takes that geometry right to the center. And then I could take a construction line here and then window all this and mirror it across. So now the only thing that's really left to do is just get in my final geometry here. Now for this final geometry, it is a little tricky because it's going from the top to the bottom here. So a lot of times what I'll do is I'll just make an offset here at 3 to act as a reference. And then I'll take that offset and make it for construction. So that will allow me to very easily create a dimension from the very top of the model here, which, I might have to kind of do the same trick up top. So take this and offset it and offset that to 3 as well. So that gives me the very top of the model, make that for construction. And then I can go from the top of the model to the very bottom of the model because that's the dimension that's actually being called out on the drawing at a height of 25. So it's like a max dimension. The angle here is 135. The angle over here is 135. And then the distance from center to center on these is 100. And then this is a sweep. And in the newer versions of SolidWorks, you can do a sweep using the circular profile option and then just type in 6. And so that gives you that sweep that you're looking for there. And so now I can take this original sketch that I created and I can reuse it. So take this original sketch, I can reuse it, and then I can do a cut extrude through all in both directions, or I could even just show it and then use that as like a convert. I could do a convert here. So top plane, begin a sketch. I could convert this line, which is ripping through the middle, and this line here, and then do a convert. Although I guess you know what? Actually, hold on. I'm going to take that back. I'm going to mirror first. So I'm going to take all this and remove this one. And then I'm going to mirror about this plane here. So mirror. I'm going to combine these two bodies. So this body and this body. are going to get combined. So I'm going to right click and do combine. And then I'm going to go and do my top plane, begin a sketch, and just make a circle that is co-radial to that original 252 circle. So just drop it right on that point. S key, extrude cut, right mouse button through all both, and this is going to be flip side to cut so that it cuts to the outside. And I got auto select for bodies there. Do a control Q here, and 517.96 or 518, 518, enter, and that is correct. And 632 for the mass of that thing, 518 grams is correct. And that is how you could model that grill shape. You could kind of model that up, speed model through that grill shape. But even though we were speed modeling, we're still following some best practices. And if you got nothing else out of today's live stream, I hope that you can appreciate that even when you're speed modeling, you know, you should still be following best practices. We could rename all the features in the tree. Somebody else could look at this later and they would know exactly what's going on with this thing. Renaming actually would have helped me along the way. It would have made it a little bit easier, but this could be called something like main outer ring. And then I just like type in something like half, or maybe if I had some of those symbols that we talked about from the character library, maybe I could drop in a symbol that indicates that it's half. This would be fillet to round stock. And I call this one outer ring. Anything that's related to outer ring, I'm going to call it dash outer ring. So like this combined down here, I would call this one merge halves dash outer ring. And the reason I'm doing that is because in SolidWorks, if you use this filter up top here, and now I type in outer ring, it filters the tree to only show me features that are related to outer, that have the name outer ring. So if you get in the habit of renaming your features when you've got like a multi-phase feature, if you get in the habit of renaming your features so that when the features are related, they use the exact same syntax, it makes it really easy for you to filter those features so that you can start making edits without having to look through, 90 features in the tree. Sometimes these models get really big when you get into these deep feature trees. What if they wanted a 7 OD, can you repair? Yeah, so that's a great question. So for something like that, what I would almost certainly do is I would use global variables to make sure that it can be changed easily. So when it comes to the global variable here, what I would do is I would go into my equation. So I would go tools, equations. What's up, Aaron? See you in the chat. How you doing, my friend? 632 for this model. Not bad, not bad. So we go in here to our tools equations. And then we would just create a global variable here. So this would be called wire diameter, and this would be 6. And then we would create another one here called wire half diameter, and this one would be equal to the global variable of wire diameter over 2. Okay, so now we've got the wire diameter, the wire half diameter, and then we would say okay, and then we would just go back to the beginning. That's the way I would do this when I'm trying to like fix up these things is I would just go back to the beginning. So I would go back in here. I would edit this sketch. So this sketch is good. We don't need anything special on that sketch. We would go into this feature. And then for this feature here, we would say this is going to equal down over enter, enter. And then this one here is going to equal down over enter, enter. So now those are both linked to the global variable for wire diameter. And then this for the fillet here, this one is going to equal down over down, enter, enter. So it's wire half diameter. And then we would proceed here. So this would be center crossbar. And this one would be equals down over enter, enter. Okay, so now that's hooked to the wire diameter. And you would, the way you would do this is you wouldn't do it after the fact. You would do it as you're creating the model. You would already have the global variable, so you wouldn't have to go back and do it twice the way I'm doing it here. But then for this pattern, so this would be called like crossbar pattern. And then this one would be equals 25 plus, and then I would go in here to, actually I would probably do it like this, equals global variable wire diameter half plus global variables wire diameter half plus 25. Probably do it like that. And the reason I'm doing that is like It's unlikely that I would, it's unlikely that I would need to, that I couldn't just do it as the wire diameter in this case, but like just in case you had like an asymmetric, that's how you would do it if it was asymmetric. And then we would go into this sketch. Don't need to change anything about that sketch. And then we would go into this. That's a body delete. So that's going to be deleting for bent wire. So we wanted that there originally because that's going to help us locate the location of the location of the replacement. We want to like maintain our spacing there as opposed to just like leaving it as a skipped instance. So this would be plane for bent wire sweep path. And then this one, the sweep, that's the actual sweep of the bent wire. So bent wire sweep. And this one would get that 1/2 option here in these offsets. So for the offset here, we would double click and we would say equals down, over, down, enter, 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 enter. And this one down at the bottom here, we would do the same thing. So this one would be equals wire diameter half, enter, 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 enter. There's probably some stuff I would have to do actually with this. Like I'd have to make this radius 6 plus 1/2 wire, blah, blah, blah. Like it depends on how the customer calls out those radii, but we'll leave it at that for now. And then there's the mirror. Don't have to do anything there. There's the merge half for the outer ring. And then there's the cutaway crossbars. And so now we should be set up where we can go to our equation here and we could say manage equations, and then we could change this wire diameter from 6 to 8. And there's this option here, automatic rebuild. So as soon as you make the change, you should see it here on the thing. So like as soon as you press enter, so if you look down there, you saw it grew a little bit. So wire diameter changed to 8 there, and then that changes it everywhere. And if we did it right, our crossbar spacing should still be 25. So if we go top plane, begin a sketch, and we take like this and this, the silhouette edge, and then draw a line between them, that line should still be 25, and it is. So yeah, good question. And that's it. That is it. Love to see me some multi-body. Yeah, we did some multi-body today. It was good. We did some pretty cool stuff today. So I think that's it. Guys, thank you. Thank you so much for joining me for this live stream. I hope that you learned a lot about modeling, about speed modeling, about how whatever we learn in regular modeling should be applied to speed modeling. Whatever we learn in speed modeling should be applied to regular modeling. You don't have to change your ways just because you're doing speed modeling. You can definitely benefit from this practice. If you visit us at TooTallToby.com, we've got a library of practice models. And what your goal should be is to go through the same model over and over again and to kind of start to remember how certain things work and start to look for things that, that can be implemented in your workflow and start to kind of think about things like, like we talked about in the previous version of this. We talked about how when you do a fillet, you could repeat that fillet by just pressing enter. And so if you've got multiple bodies, you could fillet the first one, enter, fillet the next one, enter, fillet the next one, enter, like use enter to chain those together. All those little shortcuts are going to be so helpful as you are going through your solid modeling, whether it's in SolidWorks or whether it's in any CAD system. And that's the cool thing about TooTallToby.com is that we welcome users from all CAD systems. We realize that you can learn from each other. You don't have to feel like you're siloed into just one CAD system for the rest of your career. And you can kind of mix and match and experiment with different CAD systems. So thank you guys so much for being a part of this. I really enjoyed hanging out with everybody, really enjoyed chatting with everybody. Now I am going to go and prepare for tomorrow. Tomorrow we have the the finals of our 2025 Summer Open Tournament. And I'm very much looking forward to seeing those finals. I feel like I'm pretty fast in 3D CAD, but these guys who are going to be competing tomorrow are absolute wizards. And I think they're going to light the screen on fire with how fast they are. So be sure to come back tomorrow to join us tomorrow for the live stream. If you enjoy these kinds of competitions to see if you're faster than other people, join us on Mondays. We do live stream every Monday on Model Monday Live, and it's another great place to practice your CAD skills. So thank you, everybody. Have a great rest of your Thursday, and hopefully I will see you all tomorrow.